KMUTNB's 62nd anniversary, the phase embracing the new normal, innovation-driven policies, advanced inventions, and the community unity. Education is an important foundation for human development and the progress of the nation. Adapting to the new normal of education brings unprecedented challenges and thus offers the possibility to revive the education perspectives in various aspects. Specifically, the use of digital platforms to drive learning and instruction toward transformation goals, enabling an appropriate progress into limitless information society. King Mongkut University of Technology North Bangkok, or KMUTNB, was founded on February 19, 1959, from the academic cooperation between the Royal Thai government and the government of the Federal Republic of Germany. The institution was initially called Thai-German Technical School, and the instruction scheme was based on Germany's dual education system that integrates practical training with theoretical classroom instruction. The school became renowned and was promoted to a degree-granting institution called the Thai-German Technical Institute. Later on, the name was officially changed to King Mongkut's Institute of Technology North Bangkok, and then to King Mongkut's University of Technology North Bangkok, due to gaining autonomous status. The name of the university and the emblem of Phra Maha Mongkut, or Great Crown of Victory, were graciously granted by the royal endorsement of His Majesty, the late King Bhumibol Adulyadej. At present, KMUTNB is a government-affiliated autonomous university. On the basis of invention to innovation strategic orientation, KMUTNB offers different levels of education, including vocational certificate and all degree levels from bachelor's, master's, and doctorate qualifications. KMUTNB has expanded educational opportunities to Thailand's eastern region, where the Prachinburi campus and Rayong campus were established to support and promote the growth of businesses and industrial sectors within the Eastern Economic Corridor. The innovative potential, including formal research and development, inventions and innovations of student inventors and faculty alike, have been specifically promoted. Personnel and students are able to showcase their inventions and are encouraged to attend national and international competitions. KMUTNB constantly maintains and sustains industry-government-academia collaboration with national and international institutions. The attempts bring about the expansion of new knowledge and thereby drive KMUTNB towards a leader in university-industry cooperation. Furthermore, the adoption of corporate governance principles implementing ethical governance scheme, transparency, and verifiable transactions has earned the university and its members a selection of awards and accolades that have been nationally and internationally recognized. Throughout the past 61 years, KMUTNB has shown great commitment to the development of human resources, along with its constant pursuit of strengthening science, technology, innovation capabilities. The engagements and efforts would be driving forces for national economic growth in compliance with the university policy and vision toward an internationally recognized University of Science, Technology, and Innovation disciplines.
Mr. President, the Research, Invention and Innovation Congress has been held for the second time in this year, and there are 3 main sessions with about 150 presented works, including the sessions of innovative materials, innovative electrical engineering, and innovative sustainable science. And in this year, it is a great honor to have the keynote lectures from Professor Yang Chikang from Tsinghua University, Professor Tang from Monash, Professor Yuthana from Chiang Mai University, and especially we have a special talk from Dr. Vilaipon Chetanachan from SCG, who is the innovation business guru of Thailand. In this occasion, I would like to thank the Science and Technology Research Institute of King Mongkut University of Technology North Bangkok for the hard work in organizing this conference. And I do hope that this conference will be a wonderful platform for the university faculties, the industrial people, and the innovators to share their idea and discuss on the recent research work. And in this occasion, I would like to ask Mr. President to declare the opening of the conference. Please welcome Mr. President.
Dear friends and colleagues, on behalf of the President of King Mongkut University of Technology North Bangkok, I would like to welcome you to the 2021 Research, Invention and Innovation Congress in the virtual platform during 1st and 2nd September 2021 from the previous successful of the RI2C 2019 conference. The RI2C 2021 in this category will provide a wonderful forum for you to refresh your knowledge basic and explore the invention and innovation. As the theme of the conference is invention and innovation, we have the over 150 submitted research work. I would like to encourage to the participants to find time to meet other delegates from 3 main categories, including first materials engineering, and second electrical and electronics, and the third sustainable science, who come from the RI2C 2021, comprising of the professors, researchers, students, and government staff to discuss about their experience and revolve all relationships in academic and research affairs. I would like to thank all committee members involving with the network organizing committee of the conference. Especially, I would like to thank all my colleagues, staff of the member of the Science and Technology Research Institution of King Mongkut University of Technology North Bangkok, that is the main organizer of the event. I wish this academic conference to be success and achieve all of objectives. Thank you very much.
สวัสดีครับ
สวัสดีค่ะ Good morning, ladies and gentlemen, and welcome to plenary session of Research, Invention, and Innovation Congress 2021. My name is Donanta Choi Prakong from Department of Industrial Chemistry, and I will be a moderator for this morning section.
My name is Santit Chöter from Department of Chemical Engineering. I am also moderator for this plenary session.
For this year, King Mongkut University of Technology North Bangkok, RI2C 2021 committee teams, and all of us have received a great honor from distinguished professors who are willing to share their knowledge, their experiences, and the future trends related to science, technology, and innovation. I'm deeply honored to announce 4 plenary speakers who are, first, Professor San Hua Tang from Australia, Professor Yang Chu Gao from China, Professor Dr. Yuthana Kamsuwan from Thailand, and last but not least, Dr. Vilaiporn Chetanachan.
After each of our speakers finish their talk, if you have any questions discussed related to their presentation, please be informed that you can raise your hand and then our organizer will pick you up and unmute your microphone for asking the plenary speaker directly. On the other hand, you can leave your message on the chat box and then we will ask the question for you.
So let's get started. The first plenary speaker will be given by Professor San Hua Tang from Monash University, Australia. Professor Tang received his bachelor degree and also his PhD degree from Griffith University in 1983 and 1987, respectively. After his PhD degree, he began his career at Commonwealth Scientific Industrial Research Organization, or CSIRO, as a research fellow and advanced to the position of Chief Research Scientist. He took a professor position and he has been working at School of Chemistry at Monash University, Australia since 2015. Professor Tang, he is one of the world leaders in the field of polymer chemistry, especially the area of polymer design, synthesis, by leaving free radical polymerization process. He has made several seminal contributions. Significantly, he is a co-inventor of reversible addition fragmentation chain transfer, or RAF process. The RAF invention have led to the emergence of more than 15,000 papers and greater than 600 patents. Professor Tang also published 15 book chapters and more than 160 papers in peer-reviewed journals. Also, Professor Tang have received numerous awards, and today he will be sharing us RAF pizza, a versatile to functional polymers as nano objects with various morphologies. So everyone, please join me to welcome Professor Tang from Monash University. Please, Professor Tang.
Right. Good morning, everyone. My name is San Tang, as the chair just introduced myself. I am actually from Monash University, if you can see on the screen, and I'm working currently in the School of Chemistry, Faculty of Science. And of course, it is really honors for receiving the invitation to present some of our recent work, in particular, the area called the RAF pizza. So as the chair just introduced, I was one of the co-inventor of the RAF process, which is the reversible addition fermentation chain transfer. And I suppose a lot of people are now also working on pizza. So how about RAF pizza together is the technique that allow us to actually making functional polymer, also having the morphology such as the nano objects and so on. So hopefully within this next 25 to 30 minutes, I'm going to convince you this is going to be one of the recent techniques allow you not only making a functional polymer, but it's also in nano particles or nano objects with the different morphology. And in terms of the application, which is, I'm pretty sure there will be a lot of application in the coming years using such a tool to make the nano objects. So let me move to asking you, everyone, what is a raft? Now, again, I can't move my slides. This is something is not right. I thought we have tried that before. Let me share again these slides, if I may. So everyone can see the next slides. So what is a raft? So am I talking about the life raft, like on this screen here, or the whitewater rafting in the river, or when you actually have the sporting events? No, obviously it's still the same words, R-A-F-T, called raft, but I'm going to talk about a chemistry that make use of the organic compound that I'm circulating now, which is containing a thiocarbonyl thiol compounds. This is an organic substance. Many thousand compounds been made by scientists around the world in the past, but making use of this type of organic compounds in polymerization was new back in 20-some years ago. In the 1995, we certainly discovered the application or make use of this type of material in what we call the RAF process, which is the reversible addition fermentation chain transfer. So instead, each time people have to repeat the whole sentence, reversible addition fermentation chain transfer, we take the abbreviation RAF. We drop the word C with the T, because RAFT, such as the word raft, people can pronounce, but if you put the C in between, then it's very difficult to pronounce that terms. So this is the raft process, make use of the organic compounds such as the one that I'm circulating now in the polymerization process. And we have certainly covered this technology by a range of the patents and so on. So what is really the raft process? Instead of give you a long talk, and I can say that raft is one of the current 3 living radical polymerization technique around the world, which is the major one because 1985, the first living radical polymerization technique called NMP was invented also as CSRO by Risado and Solomon. And then 10 years later, 1995, ATRP, which I'm sure the audience is familiar with, that's the atom transfer radical polymerization, the second living radical polymerization techniques. It was invented by the 3 scientists, Matejewski, Sakamoto from Kyoto University, and Virgil Perchek in Cape Westons at the time. So that is 1995. So that is the second living radical polymerization technique. Then the third one, we first published our work in 1998. But as I say, 1995, we already recognized that chemistry, and we are working really hard, to establish the chemistries from 1995 until we published in 1998. But nonetheless, the world now recognizes RAF is one of the third living radical polymerization techniques. So if you're doing polymerization or so-called living radical polymerization, most people are now make use of either NMP, ATRP, or raft. So raft is, you can say, invented 95, but its first publication in 1998. So that's by Mode, Risaldo, and myself. And you can see two out of the three techniques were invented at CSIRO, which is the one that I started working in 1986 at CSIRO until 2004 or 2015. That is the techniques that raft developing in Australia. So what is raft? Really, as I say, raft is relied on the reagent called the raft reagent, such as the thiocarbonyl thiol compound that I'm circulating now. If you want to do the polymerization of the monomer of your interest, then you need to find the right raft reagent and then put the ingredient together, carry out the polymerization. You will have the raft polymerization you're doing at that time. So what does the raft reagent look like? Because in organic chemistry, the functional group thiocarbonyl thiol can have the dithiol esters, trithiocarbonate, xanthate, or dithiocarbamate. Those are the raft reagents known in the organic literature, but make use of in the polymerization was first invented by us. And the first publication, 1998, the macromolecule, such as in here. Right, because the raft process, as you can see after you're doing it, you're basically inserting the monomer in between that functional group that I'm circulating now and the R. So in between the R and that sulfur, that's where you're inserting your monomer into it with the repeating units. So that is the raft polymer. And because it's still retaining this thiocarbonyl thiol N group, so this process allows you to further manipulation, allow you to make diblock, triblock, and even more complicated architecture. So really the raft process, once done it carefully, you should have what we're presenting in this yellow box here. All the polymer chain will have equal chain lengths. And that resulting is really nano dispersity or molecular weight distribution. This day we're using the symbol D representing the dispersity. Everything doing right, the dispersity or molecular weight distribution is around 1.05 to 1.2, or representing by the chain lengths, almost equal chain length. And of course, raft process still not ideal, not 100% perfect, because we still have some propagating radical there, or still have some dead chain. So really the raft process allow you to, as I say, inserting the monomer in between the S and the R leaving group here. So that R is representing by this light blue dot, and we certainly need a bit of the initiator. So some of the polymer chain will carry the initiator fragment, and the majority of the polymer chain will also terminate with this ZCS2N group, which allow you to do further manipulation. So if you do it well, you can make homopolymer, as I say, block copolymer, star polymer, hybrid branch, and make use of the block copolymer. You can turn them into some spherical micelle or nanogel, vesicle, and so on. So all that is become feasible once using the raft process. So again, this is organic base. We don't even need to use any inorganic salt or any metal such as ATRP. Once need to use a copper or ruthenium or irons metal. But raft is a purely organic chemistry. So therefore, this one, the process allow us to bring them into biomedical application, because things like that is people prefer not to containing any metal residues, or in the microelectronics or electronics application, because certainly raft process is a purely organic chemistry process. So once you know what raft is, I really like to say that since the publication in 1998 until now, as the chair mentioned, there's over 15,000 publications on the raft process. So in the recent years, people working on switchable raft, raft pizza, the polymerization in dual cell assembly, those are the things that you can see. I'm just using this slide to summarize all these recent advances in the raft process. Of course, there is a lot of the application, and people will also work on this stimuli responsive polymer and so on, okay? So this is just give you a little bit of background. The pizza or polymerization in dual cell assembly is one of the recent advances or a recent work that people pursuing in this raft field, as well as using the sonoraft, make use of the ultrasound to facilitate or mediate the polymerization. So combining ultrasound and the raft process, this is called a sonoraft. So today I'm going to concentrate the raft pizza and make use of the ultrasound in my talk today, okay? Right, we know a bit of the raft already. So what is the polymerization in dual cell assembly called the PISA, P-I-S-A? This is really the process first reported in the 2014 by Professor Stephen Arms in UK. What he actually the PISA process is like here in the part A, in the mechanism of raft. So if one familiar with this or understand the PISA process, then you know why they actually have the cell assembly. Because first of all, you need to have such as a water-soluble, what we call the stabilizer block. And in the presence of the monomer, initially everything soluble, but you want to have the monomer continue polymerize, but then the process further on is insoluble. The material is insoluble in the solvent that you carry out. And then they do the cell assembly because hydrophilic, hydrophobic, we already know that in water, they can form micelle. So really in this case, the hydrophilic, hydrophobic dye block is cell assembled into the nano objects. So it depends on what we have the term. This P is called the packing parameters. And this packing parameter is a very simple way to predict when you have the AB dye block or the hydrophilic, hydrophobic dye block. Hydrophilic is the one that in blue outside, and the hydrophobic is the red part, which is don't like water. When you have those hydrophilic, hydrophobic, and the packing parameters, anything less than 1, you do have what we call the spherical particles or the worm-like or the vesicle. So this is what the observation and the research outcome by Stephen Arms back in the 2014. And what he really did illustrate in the example, make use of the raft process. You can see this is the raft N group. So initially he has this PGMA is water soluble. HPMA, the second one to form the red part, initially is also water soluble. By the time you polymerize with certain degrees of polymerization with the HPMA, they actually turn into the spheres or worm or vesicle. Those are the ones that you can see in the pictures. So the areas of this, as Professor Stephen Arms suggests, they have a broad range of application. They can be a carrier for drug delivery and imaging agent and so on and so forth. And I also wanted to state it here. If you go to the literature or doing the search, raft pizza, just put this word into the SciFinder, you can find these days 250 publications since 2014. So really within the short 6-7 years, there's already over 250 publications on these topics alone. And of course, living polymerization allow you to make AB dye block so that ATRP can also do, or the NNP. But if you're using those terms NNP PISA, you only find up to only 3 publications so far. And ATRP PISA is only around 15 publications. So raw PISA is the one that is really dominated in the field. All right, so you now know what the PISA and the raw PISA look like. So we come to this field because armed with the background of the raw polymerization and understand how we make AB die block and so on. When Steve Arms making their work or illustrating the example, their raw process is actually rely on thermal, which is using thermal heat process. So we realized in that case, what if we using the ultrasound to facilitate the or mediate the polymerization? So we bring into what we call the sono raw PISA. And the examples will be illustrated on the screen here. And this is actually the work that carried out by my PhD student, Jing. This is her 3rd year now, but this is her first year back in the 2019. When I gave her this project, and I said, why don't we actually combining the raw PISA with the ultrasound? Because you can see ultrasound, the advantages, you don't really need to use an initiator to begin with, because ultrasound can split water into radical, and the free radical there were able to do the polymerization for you. So having ultrasound combining with the raw PISA, Jing actually developed these techniques. So first of all, we need to have a water-soluble macro-raw reagent, which is combining the polyethylene glycols, 5,000 molecular weights. So make sure this first one is a water-soluble one. So you are using this as a macro-raw reagent. Therefore, in the presence of HPMA, initially is everything soluble, but with time, the degree of polymerization, such as in 200 degree, the units of the HPMA, and 400, 600, and 800. You can see on this the TEM pictures here, the materials she obtained are from small micelle all the way to the very uniform vesicle particle. And you can see here are the initially that's the PEG raft, which is the one that we used as a stabilizing block, very narrow dispersity 1.02, and gradually 200, 400, and 200, 400, and 600, and 800. They all grew all the way to the increase the molecular weight. So this is really illustrating using the ultrasound, you can facilitate or mediate the raw PISA. And when we published this one in polymer chemistry, the editor inviting us to put the front cover for that particular issue. This is where you can see that issue that we published, Jing's paper. So this is the sono raw PISA in aqueous dispersion. So one good thing is you can do this nanoparticles here, doing it in water, which is very green. You are not using any organic solvent. And really high conversion, this is almost up to 99% conversions of the polymerization techniques. Right. So I already mentioned about sono raw PISA in the slide that I just shown you. But we're also knowing ultrasound can also making nanoparticle, such as the gold nanoparticle. One can actually make use of the sonication techniques. So what if we combine the sono raw PISA and also the sonochemical formation of gold nanoparticle? Because this is the publication in 2005 by one of our colleagues at Monash, Dr. Boon Tiao. She did this work during her PhD at Melbourne Uni. Knowing the ultrasound can reduce the gold solution, turn it into the gold nanoparticle. So we say, oh, that is good. Give us a good idea. Why not we combine the sonar rod piezo as well as forming the gold nanoparticle together? So would the gold nanoparticle evenly decorated onto our nano objects? And the result say yes. Again, this is Jing's work for her second year. So she basically did the same chemistry, so got the Markov reagent, and now we make use of the tertiary amine containing monomer. This one is called DMA-EMA, and then dimethyl ethyl methacrylate. So this one is really well controlled under the rough conditions, so we can do that in dioxane solution. So we are making this one first step. Then we turn it into the ultrasound technique using the sonar rod piezo, using our HPMA. So in this case, we are forming our nano objects, on this one. And then either using the gold solution or the palladium dichloride or the dihydrogen tetrachloroparidate under the ultrasound, because the tertiary amine group can combine with the gold nanoparticle. Therefore, all the gold nanoparticles are actually formed onto our nano objects. This one is the gold or the palladium. So once we can do that and we fully characterize them, and we're also realizing they can be a catalyst in a lot of organic reactions. So Jing's exploring that for her work. So this is the tables illustrate how we make them. Initially, we have the Markov reagent, the PEG reagent, and we put either 3 unit, 8 unit, 24 or 45 units of PDMA, EMA. So that's the tertiary amine containing one. And then in the next step, this is the forming the nano objects. We can turn it into 290 units of the HPMA all the way to 1,170 units. And on this table, you can see the particle size are increasing if the degree of polymerization get larger, okay? And this really actually uniform nanoparticles. Right, so Jing made this one and she do the next step with the gold solution. And really we can decorate the gold nanoparticle. If you look at this, not only the UV, you can see the UV absorption shift, red shift, but it's all that dot, black dot on the nano objects. That's little dot there are gold nanoparticle. And we make use of the electron diffraction to look at, because you can see all this concentric red, the bright dot. That really is telling us we do have all the gold nanoparticle in phase 111, 200, and so on. And once also look at the scanning transmission electron microscope using what we call the high annular dark field image, all that bright spot are the gold nanoparticles on our nano objects. So we can actually prove that this is not a really a good technique. We can actually have the gold polymer gold nano composite, and we take one of the examples to illustrate how fantastic of this gold catalyst. This one is using the 1-phenylethanol as the substrate. We carry out this oxidation or reacting with the hydroperoxide. With the gold catalyst, if a 0.1% of the catalyst under this condition is a 99% yield of the oxidizing the products, the acetone phenol. And if half of this, we still stay into 98% yield. So really only 0.05% catalyst is enough. And if we're further down, we're still retaining 77% yield. So this is a really powerful, the gold nano particle, the gold nanoparticle, as a catalyst in this application. The one that's even more interesting and also exciting to us is the palladium catalyst. We did the same thing, same way. Then you see the palladium catalyst used a lot in this called the Suzuki-Miura reaction, the cross-coupling reaction. Professor Suzuki is one of the Nobel laureates in year 2000, where the cross-coupling reaction, such as using the aryl halide, in this case, the aldo benzene substrate in this case, and together with the boronic acid, people using palladium catalysts, or by Professor Suzuki, back then they're using palladium charcoal and so on, yeah? And under this condition, the cross-coupling reaction product is 4-phenol-phenol. Now, if you look at the table here, the one that without using catalyst, only 8.5% yield. But palladium charcoal, if you're using this concentration range, our palladium nanoparticles give the same sort of the yield. But if you keep half of the concentration, our palladium nanoparticles, or the catalysts, are superior. So it demonstrates that for some reason, our polymer palladium nanocomposite are superior as the catalyst. Once again, all that black dot you can see on the TEM image are the palladium catalysts. Again, we're also using the electron deflection to quantify those particles. So all these works summarized and published in this year in Nanoscale Advance. Right, let me move on to the next topics. Once we're also doing something else, really a clever way to have what we call the gold nano composite. Not only make use of the PISA technique, but we also make use of the host gas complexation. We know that in the literature, adamantane and beta-cyclodextrin, this is almost like a cup. Then the hydrophobic molecule adamantane can actually lodge into the cavity of this beta-cyclodextrin and forming what we call the inclusion complex. Now, make use of this as our design principle. My postdoc, Dr. Paul Fan, was able to take the RAF process into the next step. First of all, take the beta-cyclodextrin. He modified that sugar-like molecule, the cup-shaped molecule, putting the RAF reagent onto it by the esterification using this DIC coupling. Once he got this beta-cyclodextrins carry the RAF end group, again, he need to put that into the OEGMA, which turned it into even more water-soluble materials. And from here, then the next one, the PISA process, again, using HPMA that we make use of in our lab, then Bohr managed to, depends on the degree of optimization of the second one, the HPMA. If a 100 units, certainly he obtained the spherical CD. And if a 200, then he observing all that morphologies in the worm-like. And then 300, then it's all the vesicle-like morphology of our nano objects. So this is allow us to doing all these nano objects, either sphere, worm, or the vesicle, do have the beta-cyclodextrin, which is the cup shape on the outside. You're realizing this is all water soluble, so that's the outer side of the particle or the outer side of the worm. Then we also again make use of adamantane through this process here. Under the RAF conditions, we make this adamantane with the PDMA, and then we hydrolyze this RAF end group using the N-butylamine you have all the capital N group. And once you know that capital N group, the SH, can bind with the gold nanoparticles. So we really making gold nanoparticle, decorate them with all outside with the adamantine, the brown color one, okay? So if you take this one, combining with either the micelle, the vesicle, or the worm CD, you can certainly see them this really decorate quite well onto the nano objects. So again, this allows us to have another way to make our gold nanocomposite with a really well-defined how this gold nanoparticles fit on our the nano objects such as worm or the vesicle or the micelle. So this is the work that Boffin did, and we published in the ACS Material Letters in 2000. Right. So we are not done yet because we're realizing hydrophilic, hydrophobic can give us micelle, worm, or vesicle that we have done using the RAP PISA. So Boffin come up another concept again that he make the water soluble, which is the stabilizing block, the PDMA with the CDPA, this is the round abbreviation, and using that to copolymerize or do the block copolymerization with the monomer, he labels a TBA, which is the boronic esters of this acrylate. Now he can turn this one into the AB die block, hydrophilic, hydrophobic. They also obtaining all this morphology depends on the degree of polymerization of this second block. Then when he actually did this work, somehow he got a lot of precipitate. Then he thought, oh, maybe the process is not ideal. Then he wanted to throw them away. But then he certainly, after done a few other experiments, when the degree of polymerization up to 250 or beyond, then he had all this solid particle. And then by the time he realized under the TEM or SCM techniques, he sees something, what we say, oh, that is something really, really cool. Because now, in that case, these packing parameters that I mentioned before, with this formula, the V is of the volume of your hydrophobic part, L is the length of your hydrophobic, A is the surface area of this hydrophilic, hydrophobic interface. If everything's below 1, that's the typical morphology that I mentioned before, micelle, worm, and vesicle. But once you get up to the really hydrophobic, the red part is dominant. And then you see the P greater than 1. There's some other morphology called the cubic phase or the cubisome or the hexasome. So this is really the confirming the particle that morphology that Paul observed in this scheme here. Then, of course, we took that into the synchrotron and studied by sex. Then we really see all these cubic phase the morphologies. We can see the 110, 200, 211 of all these particles here. So that work is just published in the year 2000. Now, let's give you very quickly, this is how we make them. And by the time 320 or 270, one's already seeing all the particles are with the cubic phase, starting from 250, right? If it's 70, 100, that's an ordinary micelle, worm, vesicle. So continue on with this hydrophobic, more hydrophobic, and then he start observing the 250, as I mentioned before, 270, 320, really, really nice. Each one is the cubic phase. Okay, so that's the GPC trace of all this polymer. And now, because let me go back. having the boronic esters, this particular group here can have some effect if one put the hydrogen peroxide, because hydrogen peroxide can destroy these boronic esters and allow them to undergo 1,6 elimination, meaning you can actually reverse whatever the object that you make back to without the morphologies, these structures. So that's how we take this particle, the assemble in response to the hydrogen peroxide. So all this one showing that if 10 minutes all the way up to 6 hours, everything's turned to back to the solution. So all these works are published in this paper. Again, I have to be quick because my time almost up. Then the vesicle, again, you can do that really clearly with the hydrogen peroxide, 6 hours, everything disappears. Right, one more very interesting, the work that we published in 2000, just last month. Today's September 1. This paper came out on the August the 10th. Now, again, this is a Jing's work. We did AB diblock. How about the ABC triblock? What would they do in terms of this pizza or the cell assembly morphology? So really, this took Jing's a long time to not only understand, because when we saw all the morphology, we were excited already, but when we actually now fully understand, we can come up with the rule, how we design them and which morphology we want. That is the center of this paper published in ACS Nano just last month. Now, again, we know styrene won't be water soluble, but we make use of the beta cyclodextrin, which we have done in the previous work. We can turn the styrene into water soluble. Okay, on this scale here, the styrene can actually lodge into the cavity of this cup and become water soluble. So the first one, you can do that. And the second one, another very hydrophobic monomer, such as the tertiary butyl acrylate, we can actually make the ABC triblock. And it depends on the degree of polymerization, depends on the order of the B block or the C block. This is really the morphology we come up with. It can be like a dumbbell and can be tetrahedron-like morphology. And even if we change the order of the block, choosing the low TG for the mid one or the higher TG, the mid block, what Jing observed is not only we have this kind of almost like the pea, we're eating the peas and the pea pod morphology, link them together, or the raspberry-like morphologies. So it depends on the TG. So here we summarize our discovery by having the ABC triblock. It depends on the surface tension of the hydrophobic part. We can have either the core shell corona, the pea pod-like, the raspberry-like, or this is colloidal molecules, we term them. So really, the powerful of this techniques allow us to make a lot of different morphology nano objects. So with all this, I think my time is almost up, and I'll give you a bit of the summary. RA processor developed when I was a CSRO. We took that into Monash for teaching the student doing their research, combining with the ultrasound or the sonochemistry. And we also realizing we can do a step better in terms of controlling the morphology of the nano objects. So this is what we discover. And I can convince you, RA processors are powerful and it's a scalable techniques to make the polymer nano objects and allow us to make a lot of different things and remain for the world to actually do the application for these techniques. And with all this, I need to really give thanks to the Monash team. Today, I only present the work by my postdoc, Bo Fan, and my PhD student, Jing. She will finish her PhD at the end of this year. hopefully she will retain in my group to continue on her beautiful work. So I need to give thanks to previous the RAF teams back at CSRO, and also I spent 4 years in Beijing. So this is the team. Currently, I have a funding from Australian Research Council as well as the Centre of Excellence, plus the two commercial company BASF and CSL locally give us a lot of funding. And with that, I thank you for your attention.
Thank you, Professor Tang. Any question from the audience, please? You can turn on the microphones and ask Professor Tang directly, or you can put the question in the chat box, and then I would grab your question and then ask to Professor Tang. Any question?
Maybe the audience is shy. Yeah.
If there is no question, so let me ask one question.
Mm-hmm.
So first of all, I'm totally impressed by morphology and the chemistry that you have been decorated. And I think like it's such an awesome job for your group. I am feel interested in palladium composite catalyst.
Mm-hmm.
It seems like you decorate, you have the core as palladium, and then you second block, it seems like you fix number of the monomer for the first block, and then the second one, it seems like you vary and you still see the efficiencies of the catalyst. So I am wondering that whether you have tried increase the number of the second monomer and what happened with the morphology, including the catalyst efficiency.
Okay, so this is something it currently is beyond Jing's investigation. I'm having a student coming towards the end of this year.
Oh.
The student actually going to explore further and define better. But the catalyst already so effective. Yeah. We haven't seen anything down to that level of the concentration and still give us a very good yield of the Suzuki cross-coupling reaction. And it's really, really so powerful. Yeah. And not only that, we have done gold, we have done palladium. So what we are planning to do is a silver nanoparticle based on the same thing. And can we actually eventually have gold silver mix or gold copper mix, silver and copper mix? That is the field that we can explore. Yeah.
Yeah, I can see that you add just less than 0.5, I think 0.04%, but the efficiency is quite
40-60% yield of this Suzuki coupling reaction. Yeah, it's amazing.
Yeah, I mean, in general, like catalysts probably add to the system less than 5%, but this time you add even less than 1%. Yeah. And it's still like work an awesome job in the performance and the products that come out is still great.
Yeah, initially it's too good for me to believe, but then I say present all the evidence and show me, and then repeat and repeat. Okay. Yeah. Okay. I'm so convinced. Yeah.
Okay. So there any question from the audience? It seemed like you make every point is quite clear.
And I'm advertising now. If next year after the COVID, and any Thai student wants to come to my lab, I'm always open and welcome. Yeah.
Okay. All participants.
We can certainly establish a collaboration further.
Okay, that's great. So all faculty and also the PhD student or even master student from KMU TNB, please make a note. So Professor Tang Group already welcome you all to join his group if you feel interested in RAF. In particular, combined with nanotechnology, I would say. So it's such an interesting talk, and I'm quite impressed in person. So everyone, please join me to thank Professor Tang from Monash University. And so, and we're gonna move on to the second plenary talk.
Okay, now let me introduce our second honorable panelist speaker, Professor Yang Zhigang. Professor Yang Zhigang received his bachelor, master, and PhD in materials science and engineering from Tsinghua University, China in 1989, 1993, and 1996, respectively. After his PhD, he joined a School of Materials Science and Technology and Engineering, Tsinghua University as a lecturer, and he has been promoted as a full professor in material science since 2004. Professor Yang is currently a research group leader of the Key Laboratory of Advanced Materials of Ministry of Education. His research interests are on the phase transformation in metallic materials, heat-resistant steels and alloys, and high-temperature oxidation of bond coating and coating materials. According to his expertise, he has published over 160 publications in academic journals, 2 monographs, and 2 textbooks related to his expertise. To confirm his academic reputation, he received numerous awards, which includes the Academic Young Scientist Award of Tsinghua University, New Century Excellent Talent in University, and the Second Class Award for Science Progress given by Ministry of Education, and also DuPont Innovation Award. Our next speaker, Professor Yang, is one of the most outstanding professors in material science and engineering, in particular the phase transformation in metallic materials. That's why we brought him out today to deliver his experience on the plenary session entitled Alloy Elements Partition Effect on phase transformation kinetics in steels. So everyone, please join me to welcome Professor Yang Zhigang. Please, Professor.
Okay, thank you, Chairman, for invitation. The previous talk is on polymer. It's a very popular material in the world. We can see everywhere. My talk is on another very important material, that is steels. It's the most popular used steel in the world. Almost even in China, we have about more than 10 billion per year output. So my topic is on the alloy element partition effect in the phase transformation of this very important material. I'm from Tsinghua University. Okay. Something wrong? Oh, something wrong. I can now move my.
Okay, so I think you can stop sharing first, and then you try to share it again.
Okay.
Okay.
There again. Okay. Is it working now?
Huh? We can see your screen, but I don't know if you go to the next slide.
Okay. Okay, now it works. I'm sorry. I'm sorry for the inconvenience. So, as I said, steel is a very popular used material in industry. It's a very simple composition, but it have very complex structure and properties. We can make it soft, we can make it hard, and we can use it everywhere. So the principle of these different properties is based on the different structures. this structure is from the very popular phenomenon that called phase transformation in steels. So this figure we can see, when we heating the material, we can get a homogeneously make structure at high temperature. We call it austenite. And when cool it, we can get sometimes called ferrite. It's actually from iron, the name from iron, and also bainite and martensite. As you know, bainite is named by the person who observed first bain, and martensite is named as the marten. So we can see they are quite different. So different make structure will result on different properties. That's the reason why it's so popularly used. For example, we now developed advanced high-strength steel stress steels by different design. We just use iron carbon manganese system in addition to some silicon, or recently they are aluminum also. So we can see we can get different kind of steels. The first generation steel for automobile application is around this line. This is the total elongation. This is the strength. So usually, as the increase of the strength, the total elongation will decrease, and a lot of steel is around this line. Now people have added a lot of manganese in this steel. They can get the second generation high strength steel. Is called tube steel. It means twin induced plasticity steels. And recently, we are developing the third generation advanced high strength steels. This called, we reduce the manganese addition to metal manganese, and this steel have a moderate elongation and tensile stress. So the combination of this elongation and stress gives good properties, and also considering the price and the processing ability. So if we want to get good property of steels, we need to have a good spec structure. To get a good structure, we need a good processing, and all this from the very simple composition. Usually is a little carbon, a little manganese system. So phase transformation is the key to plan and design the complex structure of the advanced high-strength steels. So steel, very complex phase is shown like these two fingers. So this, the left one is a very well-known iron carbon phase diagram. This is temperature, this is iron, this is carbon concentration. So we can see this area is for steel, this area is for cast iron. So even for steel, this the carbon concentration is up to 2%. But for a lot of steels, low carbon steel, we are along this area. This area is maybe less than 0.8 or 0.7% carbon. Even for this area, we can see we have at high temperature, we have austenite, at low temperature, we have ferrite and bainite, etc. So when they have different structure, this is equilibrium case. But if we consider kinetics, we can see that even in this area, we cooling it in different rate. We can go from a high temperature austenite to coarse and perlite, fine perlite, up bainite, low bainite, martensite, or different structures in different cooling rate. We can see here. So actually, the industry case is not equilibrium. We can got a lot of structures. I'll show you some picture to see what is it. So this is a typical structures for the steels. So we can see from high temperature austenite, when it's low cooling, we can get this ferrite plus perlite. Sometimes you can get almost pure perlite. This dark one is perlite, and the light one is ferrite. This we call the high temperature transformation product. So if we quench it very fast, quenching it by water, we can get a martensite. That is the reason why we get very, very hard steels. For example, for the tools, for the knives, So this low temperature transformation product is called martensite, like this one. And if transform this into the middle temperature regions, we quench it in a moderate rate, we can get such kind of structure called bainite. It's something like martensite, but something also like ferrite. So it's an intermediate case. So now there's so many transformation case. So in this presentation, I was only focus on this very simple one, from austenite to ferrite transformation. This is a very simple one, and we want to study the kinetics of it. So it's a diffusion controlled kinetics or diffusion-less kinetic process. So my contents are usually concerning the four part and diffusion carbon or diffusion of a long element, that means partition or negligible partition, local equilibrium, and an example is AR3 by this theory, and we can apply it and to define some chemical boundary in the phase transformation. Okay. So when phase transformation happens, so there are two processes. For example, during ferrite transformed from austenite. So there one is the structure change. The austenite is a FCC phase cubic and to R phase as a body cube crystal. Also there are composition changes because the carbon in the ferrite is very low. In austenite is quite high. So during the movement of the interface here, we can see this is growth directions, and this is the carbon concentration in ferrite. This carbon concentration in austenite. So this is equilibrium partition. So if it's diffusion control, that means the carbon will diffusion profile like this one, and this growth rate is controlled by the diffusion rate of these curves. It moves this way. So we call it diffusion controlled growth. In other case, if it quenches to a quite low temperature and it grows very fast, they have a concentration profile of carbon like this one. This is called almost no diffusion of carbon. We call it interface control. Actually, in the lot of cases, it's the concentration profile like this one. It's we call it mixed control. It's controlled both by diffusion and the interface reactions. So this too complex. So I only confirm on the diffusion control of the ferrite growth from austenite. So it seems to be quite simple. Okay, so the diffusion control ferrite growth rate, it can be solved by some typical classical theory of diffusion. For example, a fixed diffusion law, and we consider the mass conservation of the carbon. So we can get the profile like this one. And if we further make some approximation of these curves to a direct line through the linear way, we can make these equations, the numerical this equation is quite simple. So that means the partition of the interface equals to the R and diffusion coefficient and the time. So here R is a parabolic growth rate, and the velocity is also proportional to the parabolic growth rate and the diffusion coefficient of carbon, and this is the time. So it's very simple. Of course, this is not always the truth because it's make a lot of approximation, and it's only for one dimension growth. But generally, there's experimental data to agree that the theory, for example, in some experimental data in the iron 0.5 atom carbon system, they measure the thickness of the ferrite, and with the time and grows at different temperature. We can see it grows quite well. Now, if we consider that the lot of steels not concern only carbon, that has a long element, so we call it a substitutional element. So carbon is an interstitial element. It diffuses quite faster, but substitutional atom diffusion coefficient is about 4 to 6 orders smaller than that one in the area of in temperature range of our interest here. So diffusion of a long element, for example, manganese, nickel, or other elements, is the key to control the diffusion rate if it diffused. But it's not always diffused. So there are the 3 models in iron carbon long element system. We call it the peri-equilibrium, also equilibrium, and also equilibrium concerning PRE and NPRE model. Peri-equilibrium is that we consider only carbon is in equilibrium, a long element no equilibrium. It's just neglect a long element. So we call it not real equilibrium, it's peri-equilibrium. For the also equilibrium, is all carbon and substitute elements is equilibrium at the ferrite austenite interface. But the partition of a long element may happen or not happen. If it happens, we call it a partition local equilibrium. If it not happen, we call it no partition local equilibrium. Why we can diffuse this different model? Because different models use different growth rate remarkably. So for the case of peri-equilibrium, we can get the manganese concentration like this one. So we can get the carbon concentration like this one. So this is a carbon control diffusion. And for the case of partition local equilibrium, we can see this manganese diffusion control the growth rate. So the manganese profile like this one. So these 2 cases, we get the equation for the growth kinetic like this one, and this supersaturation. So we can see this is diffusion coefficient of manganese, diffusion coefficient of carbon, just only different like this one. So the ferrite, the ferrite growth is very, in this case, is very faster, and this case very slow. And this R is a parabolic growth rate. For the non-partition local equilibrium, the equation is a little complicated. I will not talk in detail, but I just show you that it's related with the diffusion coefficient of both of them. But anyway, this way, NPRE is also a quite faster growth rate is compared with this PRE, and is a little less than this P. So this the temperature, this is the parabolic growth rate constant. We can see that for the PRE model, this is quite lower. For the NPRE model, this is quite faster. So this, as temperature decrease, we can see the ferrite growth from one model transform to another model. But the very significant difference is that the growth rate constant increase very fast. So we can see at this temperature, there is an abrupt change of the growth rate from slow growth to fast growth. Now we can see that in the NPRE case, there should be a peak of manganese at the interface boundaries. Now, due to the high technique observation, we can see that there rarely have interface boundary of manganese. This is only about several tens nanometers in size, and it's very high peak here. If we isothermal treat it for long term, we can see that this peak is almost disappear. So people, it's difficult to observe this peak because it's only exists at a small time, and the long term it may be it will be smooth. So there's series, and now we compare with experiments. We can see for the case of iron carbon silicon system, we can get the experimental point. This point is agrees with the P and NPR model both, because in this case, silicon is almost similar, like not very significant effect on the iron. So these 2 models are similar. So we can you can see the temperature range below 800 centigrade. Transformation is followed by the MPRE or PE model. For the case of iron carbon nickel system, we can see that the PE and MPRE are a little different, and we can see the experimental data around here is close agrees to the MPRE model, but temperature range below this temperature. At high temperature, it is very, very slow. For the case of iron, carbon, silicon, and manganese system, manganese have a lot of concentration, a lot of interest in the steel study. We can see that this equilibrium curves, and this is MPRE, this is PRE. The experimental data is around here. So at the low temperature, we can see maybe for case below 700, we can see this is around, this is close to the MPRE model. The high temperature, this close, the experimental data close to the PE or it's PRE between them, and not very exactly. So it's very complicated. Now we show you some microstructures for a typical study of steel, iron, 2 manganese, and low carbon system at 500 centigrade, and 650 centigrade, and 725 centigrade. We can see at a very low temperature, this this structure is quite different. This actually we call it bainite. Okay, we do not talk it anymore. We consider only ferrite. So at the high temperature, the two temperature, the ferrite fractures are quite different. This case, we can get a lot of ferrite, but in this case, it's quite slower than this one. Of course, the temperature difference is very important to determine the different microstructure. The kinetics are different. So we studied the case, the carbon concentration in the austenite and ferrite in two systems, in two competitions. One is 0.05 carbon, one is 0.14 carbon. Both are containing 2% manganese. We measure by EPMA, by some precise measurement, we can measure the carbon concentration along the austenite. When we actually austenite, we quinceed to room temperature is becomes to martensite. So we can see the carbon concentration in the austenite is 0.3, and in this case, it's also nearly 0.3. So they are not so much difference. But at the ferrite, the carbon concentration is very, very low, like this one, much less than 0.01 maybe. So this point, we can, from phase diagram, we can see when the austenite transform to the ferrite during cooling, there are several curves. These curves agrees with different theory. So this one means also E3 temperature, and this one is peri-equilibrium E3 temperature. That's I just talked before. And now this curve is PRE MPRE transformation lines here. And the experimental measure, the carbon concentration in these two alloys agrees quite well along this line. It's not follow on this also equilibrium or peri-equilibrium. It's just drops on the line exactly for PRE MPRE transformation. So it can see that this PRE MPRE transformation is very important to determine the phase diagram, phase transformation kinetics. Now for the case, another case is for the iron carbon nickel system. The experimental method competition is almost close to the calculated PRE MPRE transportation line here. So it's called here, they marked as zero partition in this case. Now we do some carefully experiment to see its difference even just below or under the PR-MPRE transformation temperature. So we heat it to the high temperature to get austenite, then we isothermal treat it at different temperature. So this only 40 or 40 centigrade difference for the four case. We can be treated 5 minutes or 10 minutes. We can see the back structure like this one. They are quite different, especially finger B and C. The finger B is isothermal treated at 700 centigrade and finger C is 710 centigrade, only 10 degrees, 10 centigrade difference, but the max structure, the fraction of ferrite is quite different. So that means there may be a model change between the two temperatures. So we can guess they are between the two cases. The temperature is between 700 and 710 centigrade. And we get the percentage of ferrite with temperature like this one. We can see our significant draft around this temperature range. And we calculate this PR-MPR transformation temperature like this one is about 708 centigrade. So it's agrees with experimental data. Now we notice that this transformation changed with PRE to MPRE with temperature, but not only with temperature, it also may with time. We can see it's initially it's PE model, and then it's MPRE model, and then it's PR model. It changes from carbon concentration diffusion control change to the manganese diffusion control. In the initial stage, early stage, ferrite grows from austenite. There's no partition of manganese, and then as ferrite grows and the manganese peak appears. So this is a NPR model, no partition local equilibrium model. When it increases to the equilibrium case, and then at the long term, at the final stage, the peak of manganese will be diffused. So the kind of manganese profile like this one. So this is this is the partition local equilibrium case. Now when we start this, we notice that when cooling from the austenite to ferrite temperature, we can see there are several lines. So this is also equilibrium AE3, and this is para-equilibrium AE3. And there has a PR-MPRE temperature here. So we have observed that activity, when it cooling down, this activity transformation transform model from slow model to fast growth model along this line. So this line is very important. In industry, we have AR3 temperature, which is named as the start temperature of ferrite appears during continuing cooling. So usually the measured is a very slow temperature, slow cooling rate. For example, 1 centigrade per minute, like this one. So this AR3 temperature decrease with increase with the cooling rate. So the highest case usually we measure it like as the AR3 temperature. Now this AR3 temperature we can see it's from experimental is around this temperature. This measured by from some books, and we calculate this one. We happen to find that the calculated PR-MPRE is just similar as this temperature. So now we calculate the more system and calculate from the PR-MPRE temperature and compare with the experimental AR3. So we can see that AR3 and the PR-MPRE transformation temperature is very, very close. Usually it's about less than 10 centigrade. So we try to find more in most case. So we tried to more case, we can see that in the case of iron, carbon, and manganese silicon system, the PRE temperature and AR3 is within 10 centigrade and within was something wrong? Something wrong? Okay, okay. So if we use the 20 centigrade range, we can see like this one. So it's quite agreeable. So from now, so we notice that the importance of manganese partition or not partition resolved on the different, quite different growth kinetics. But actually, it's very simple, like simplified. Actually, if there is a manganese peak at the interface like this one, it has some bonding effect with the interface, so it will reduce the interface mobility. So there's energy that is needed to consume by this bonding effect. So we can see that the slow growth rate, the profile is like this one, and the cooling, the low rate is like this one. So we can see that a lot of energy will consumed by the manganese bonding effect. So that means we use another theory, we call it deep energy balance model at the interface to solve this problem. We can see this case, the result can be contains local equilibrium and peri-equilibrium. That is DB model. We found that beginning the short time as manganese no partition PE NPN model. Then this is GA model. DB gives the result for PE and NPRE. We can modify, we can change the bonding energy of manganese to interface that we don't know exactly, but we change it. We can see we can get the result. This is for local equilibrium, IE, this is PE. We can agree with that. So we can use the 3V model to describe the kinetics more reasonably. And of course, we did not concerning the mixed model of the interface. The interface reaction rate also plays some role. So then for case for the slow drag effect, we do not talk it. And we can also see this not happens only during heat cooling. It also happens during heating. So if we heat the steel, we can see at the lower temperature, there are manganese diffusion control. At high temperature, there's no manganese diffusion, it's carbon diffusion control. So there's also a partition point we call the PNTT, partition to no partition transform temperature. So above this temperature, it goes very fast, and below the temperature, it's transformed slower of austenite. So now we can find that there's a chemical boundary in addition to phase boundary and the green boundary. So even in one phase, we have the different composition. So the composition difference, we call it chemical boundary of the material. So for example, we can use the chemical boundary theory to get a different microstructure. We get the austenite reverse transforming treatment like this one. We get austenite grows from ferrite. There's austenite is manganese rich and ferrite and manganese poor. If we fluctuate it, we can get the interface grows very faster, but the chemical boundary grows slowly, so it's below it. So then we can hit to high peak. We can get the microstructure of austenite have some part is full is a rich manganese, some part is a poor manganese, and we heat it. We can get martensite forms in the poor manganese system, and we can get the martensite is limited by this chemical boundary, so we can get refined microstructure compared with this without flux. We can ordinary ART transform temperature. The tin austenite fraction is almost similar, but this case is much fair. And you can see usually the refined microstructure result in good properties, especially the good toughness. So that case, we can get a core cell structure, core cell austenite by this flash heating. So we can see the manganese profile like this one in this case. So we can see there are the cells of a high manganese cell and a low manganese core. And also we can use this in another way. We can flash heat it at the beginning. In this case, we can get the quick growth of austenite cell which has low manganese and then have a high manganese core cell in the outside layer, and we can get austenite with a core cell microstructure. And this cell of full manganese austenite, they have a very stable mobility. It can, when it coincide, it can keep the microstructure of retained austenite and without transformation to martensite. So that case, we can get the ferrite and the austenite. We can see in the no flash case is about this about 37% retained austenite. But in the case we get flash treatment, we can get more austenite, about 10% more than this case. So this this is more austenite is very important. So when we use it as chip steel, more retained austenite can give more plasticity and more toughness, and this very useful. I will not talk in detail the properties. We have done a lot of experiments on properties. It's really improved the mechanical properties. So this case of the core cell structure. So now to the full understanding of the effect of austenite of the alloy element in phase transformation in steel is actually is still on the way. Steel is a very, very simple and a very traditional material, but a lot of theory is still unsolved. For example, the diffusion control or interface control or mix control and carbon or substitute alloy element diffusion or not, and the different model with time and temperature and the effect of matrix deformation. I have no time to talk it. So actually, they form the austenite, they form the ferrite have a lot of effect, and cooling rate and heating, and also in the industry case, there's cementite. It's a three-phase transformation from ferrite, cementite, and austenite. So in that case, the theory will be refined to apply to this three-phase system. And now, thanks for your attention. And we have actually we have international phase conference on solid phase transformation in 2020, but due to the coronavirus, is delayed to this year and still delayed hopefully in next year. It's a very important conference, as every 5 years start from 1981. So I hope some interested can enjoy it if it happens in 2022. Thank you for your attention. Okay.
Thank you, Professor Yang. So any audience have any questions? If you have any questions, you can raise your hand and our organizer will pick you up and unmute your microphone for asking the Professor Yang directly, please.
อาจารย์สันติ I have just one question.
This,
Hi, good morning.
This work is quite theoretically, so not easy to understand maybe in short time. We can
waiting for some audience if they have any questions. So I think this work is quite interesting in terms of the material side. So basically, I'm on the how to say like bio process. So on looking for the material composite or like this, I think is quite very interesting. Yes.
Yeah. This, actually, a lot of very, very complex phenomena is still very interesting. We do not understand actively.
or the theory that you mentioned and you described during how to say like all the phenomena and thermodynamic phase diagram is remind me when I was the chemical engineering student.
Yeah. So chemical. Actually what I talk is related to chemical. That is the substitute elements, the effect on its theory. People usually just ignore it. Usually, they contain only 1 or 2% alone element, and a lot of is iron. So and carbon play important role. People know that, but for alone element, people lot of cases they just neglect. But recently, with more carefully work, we noticed that alone element is very important, and
Okay.
it diffuse or not is plays a very important role. So that's the key, I think. Okay.
Okay, so right now we have the audience from the chat room, I think the lobby room. So I think our organizer will pick the audience have to ask the questions.
Yeah, welcome.
I think Professor Somrek would be the first one who asked the question.
Yes.
Maybe we're waiting for his question.
Okay. Hello, Professor Yang. Can you hear me? Hello, Professor Yang. Hello, Ajahn Kwong, you hear me?
Yes, I hear you.
But I'm not so sure if the Ajahn Santi cannot hear me.
Okay. If no further word, no further.
We might have
Professor Yang, could you hear the question from the Professor Somrek?
So what
Good
question?
morning, Professor Yang.
I cannot hear what his question. I do not hear any question.
Okay.
I do not hear any questions. Is means his microphone is not not open.
So normally he unmutes his microphone and he asks directly the questions to you. But
Ajahn Santi, can you hear me? No, not yet.
Yeah, I can hear.
okay, we can hear right now. Okay.
Yeah.
So
Okay,
please,
Santi, can you hear me
Professor
now?
Somrek, can you ask him again? Yes, we can. Yeah.
Yeah. Good morning, Professor Yang.
Okay. Good morning.
Okay, it's nice to see you, and I would like to thank you for your acceptation to be the keynote lecture for today. So I think your talk is quite interesting, and in fact I have just some few questions, because in fact I also work in high temperature corrosion of stainless steels, and I also see diffusion of manganese through oxide scale. We know that manganese can diffuse fast through the oxides, but in fact I don't know the reason, and I think this phenomena is seems to be similar in phase transformation of steel. And then I have just some basic question that why manganese is can diffuse faster or is important. This is my short question.
I do not follow your questions. So manganese diffusion faster? You mean what?
Yeah, right. Do you have any reason for the effect of manganese, why it is important in the diffusion process?
Yeah.
This is my question.
This compared with carbon diffusion, manganese diffusion is very slow. Yeah. So that means it's very slow. So if it diffuses during phase transformation, the kinetics, the transformation happens slow. So if it did not diffusion, just the carbon diffusion, so it's very fast. So this is my key. I do not. Is that what you answer?
And in your case, you study manganese diffusion effect.
Yeah.
From ferrite to austenite.
Yeah.
Okay, and it affects some mechanical properties.
Yeah.
Yes. Can you explain more about it?
Yes, there are quite a big effect on the mechanical properties. So due to the limited time, I do not talk it in detail because they change the mag structure fractions. So the mechanical properties is changed remarkably. So that's true. So we can use this theory to produce some steels with what we required properties. That we can do that. Yeah.
Okay, this is my question. Thank you very much, and thank you again for your coming to joining us.
Thanks for question. Thank you for question. That's very important. Yeah, that's the reason why we started. Okay.
Thank you. We have now another audience for the questions, please.
I cannot hear.
Yeah, right now it's okay.
I have some question about you use diffusion model to explain manganese diffusion. How about carbide forming? Is this model can be used to explain the carbide forming process?
Yeah. That's a very important question. I do not talk it. As this question remind, when the carbide formation, there's a lot of things to study. It's generally we can apply it, but we need to consider much complex phase. So the diffusion path, it's diffusion along the interface, or diffusion along the green boundary, or diffusion from the interface between austenite and ferrite. So that makes the diffusion quite different. But generally, it works. Okay. Yeah, but much more complex. Actually, in steel we have carbide. So carbide formation is also very important.
Thank you very much. Very interesting presentation.
Yeah. That's true. You get the point.
Okay, thank you. So I think we have another audience for questions as well. Please. So it might be a little bit delay for switching from the audience at okay, she's here.
Yes, okay, thank you. So I will close this there.
You can stop share, yes.
Okay. Can you hear me? Yes. Okay. My question is, as you mentioned that different mode of PLE and NPLE was found when cooling to the different temperature from the austenite to ferrite. So do you think that the cooling rate actually affect the PLE or NPLE mode or not?
Okay. This cooling rate actually is have some effect, but the effect is happens by, I think, by the transformation start temperature. So actually, we think this is also a dynamic case. It's cooling, transform, and cooling. So it says very complex. We need to started step by step. We cannot make a very very simple case. That's yes, you are true. That have some effect. Couldn't read. Yeah.
Okay, thank you very much.
Yeah.
So I think right now we run out of the time for Professor Yang right now. So if you any audience have any question, you can leave your question in the chat box and we will grab it and we will send the email to the Professor Yang and he will respond directly to you. So again, thank you very much Professor Yang for his interesting work on the phase transformation kinetic study in steel. So right now we are moving to the next third plenary talk. The next plenary speaker is Professor Yuttana Kamsuwan from Thailand. Professor Yuttana received his bachelor, master, and PhD in electrical engineering from Thailand. After his PhD, he joined Rachamankala Institute of Technology and the co-lecturer at Chiang Mai University. And he has officially joined a Department of Electrical Engineering at Chiang Mai University since 2011, where he is currently full professor in electrical engineering. During his academic career, he was a visiting professor at the Texas Austin University, USA, and the Department of Electrical Computer Engineering, Ryerson University, Toronto, Canada. His research interests are in the area of the power electronic applications, electric drive, and renewable system. According to his expertise, he has published over 80 publications in the academic journals. He is an active member of the IEEE Industry Electronics Society and Power Society. He served as an associate editor for ECTI EEC transaction. Professor Yuttana also served his expertise and shared his experience in several international conferences. Since he has been as a well-known person in electrical engineering, he received several awards, including the WE Conference Paper Award in 2014, the IE Conference Industry Electronics Society Paper Award in 2016, and the ECTI Conference Paper Award in 2013, 15, 16, and 20 respectively. Unfortunately, he could not join the online plenary session today, but actually he would like to join us in the virtual platform. However, he provides his record video presentation of his talk for sharing us in the this plenary session. His talk is entitled Commode Voltage Mitigation for the New 9-Switch Voltage Source Converter. Please welcome Professor Yuttana.
Hi everyone, getting from Chiang Mai University, CMU, Chiang Mai, Thailand. I'm Yuttana Kamsuwan, and thank you the committee to invite me for presenting in this conference. Today, I am going to talk to you about the common mode voltage, for short CMV elimination in voltage source inverter VSI and its applications, especially the three-phase motor drive and gate interfacing or gate connected applications. Well, there are three highlight topics, including the basic concept of the voltage source inverters for the first topics. And the second topic give you in the detail of the three-level inverter and how to eliminate the common mode voltage CMV of this inverter. And the third topic is you in the details of the new topology, namely 9-switch inverter and some modulation techniques to reduce and eliminate the CMV for this inverter as well. So let's turn to the first topics. That is the voltage source inverter for choice VSI. The function of the inverter is to convert the DC voltage to the T-phase AC voltage by using power width modulation PWM technique, which can control and adjust both the magnitude and fundamental frequency at the output terminal of the inverter for applying to any loss, such as an AC motor drive, UPS, and gate interfacing application as well. That is the main benefits of the inverter. Here is the general inverter structure. The left-hand side here is for the two-level inverter, and the right-hand side is for the three-level Newton point clamp NPC inverter, which are the common structure used in industrial section. The use of the switching states is P and N to control the two-level inverter, and P, O, N states are to control the three-level inverter. So to generate PWM line-to-line voltage at the output of inverters, for example here, the conventional sign modulation or SPWM method for two-level and three-level inverter has developed. In picture here, these pole voltage inverters are in line with the PWM getting signal. Finally, the sum of these pole voltage is generated PWM line-to-line voltage waveform at the last picture waveform for the inverter. One is the T step level for the two-level inverter, and also is the 5-step level for the T-level inverter. Of course, it is very simple to implement. That is the basic concept of the PWM method to generate the line-to-line output voltage waveform of inverter. But the question is, what are the indicators for the output performance for this waveform? So the performance evaluation of PWM methods is mainly in terms of the DC utilization, which depends on the PWM techniques. Currently, there are two common methods shredding, namely sine and non-sine modulation carrier-based methods, and the space vector modulation for choice SVM method. The other performance evaluation is the waveform quality by using the total harmonic distortion THD of both voltage and current at the output inverter. So for example, for the multi-die applications, the line current THD is a widely used performance measure. In addition, a knowledge of voltage harmonic spectrum is required for different purposes, including the filter design. This is particularly important in gate interfacing or gate connected applications. So once again, in this picture shown in this slide, the PWM line-to-line output voltage waveform of two-level and three-level inverter from the right-hand side and left-hand side, respectively, are their harmonic spectrum in the same condition at the flow modulation index AM to be 1. Although the DC utilization for both inverter is the same value, the THD of the voltage of the 3-level inverter is better than 2-level inverter significantly. This is due to the PWM multi-level waveform with attractive in the low switching frequency applications. Of course, as mentioned before, the use of FFT of the PWM output voltage is to evaluate the harmonic component. So, and here, this picture compares the two PWM methods. The first one is sine and non-sine PWM with calibrate method. You can see on the left-hand side. This strategy is suitable for the analog implementation to generate the PWM getting signal. The other is the SVM method. You can see from the right-hand side. It's suited for the Lincoln implementation. In addition, this modulation is required the spectral theory to make the PWM algorithm. However, the main challenge is still the DC utilization and the waveform quality. Remember, challenging in the DC utilization and waveform quality. So let's move on now and look at the picture for comparison in terms of the DC utilization and waveform quality for the two PWM calibrate and spectral-based SVM methods. And again, given the same parameter here to evaluate this performance, I would like you to concentrate on this box, on the DC utilizations box here. The DC utilizations for both PWM methods is the same value, but the harmonic profile of the SVM methods or spectral method for the 3-level inverter is better waveform quality than calibrate PWM method. Is it very interesting to adapt this inverter in the case of high quality requirements at the output inverter? And here, the plot in this slide show a comparison of the THD of the output voltage in function of the modulation index change from low value to high value. And you can see here, the THD of the voltage of the 3-level inverter is lower than the 2-level inverter for the entire modulation index in the linear length. Of course, this inverter is attractive to medium and high power applications when compared with the 2-level inverter. So once again, inline current THD value pertaining to 2-level and 3-level inverters with low and high modulation index values are shown in this picture. From the pictures, the 3-level inverter is better waveform quality than 2-level inverter. This helps to reduce the ripple components and the right current, reduce switching losses, and improve the harmonic spectrum also. Now, I will show you the ones of major problems for both inverter when the use of PWM switching actions. This PWM inverter also cause high frequency, high level, especially a common mode voltage, CMV, is generated in the system. In the picture in this slide shows the waveform of CMV for the 2-level and the 3-level with both calibrate and SVM methods. You can see here from the CMV waveform, there are 4 level steps for the 2-level inverter with the maximum magnitude of half of VDC, and 5 level step for the 3-level inverter, but the maximum amplitude of 1/3 VDC. So this alternating CMV results in varying currents by electrostatic coupling through parasitic capacitance. The inverter generate CMV also cause motor leakage current, or it's called another name in the common mode current, CMC, which act as the source of electromagnetic interference, EMI, in the motor drive system. And another harmful effect of the CMV in the generation of the charge voltage across the motor bearing that may cause disruptive electric discharge, machining, and danger to use from electric shock. It's very dangerous. So I would like you to concentrate on this simulated result for a high performance vector control AC motor drive system with the 2-level inverter from the left hand side, and the 3-level inverter result from the right hand side. Actually here, although the forecast operation is termed of torque, speed, and output PWM waveform, and the 3-phase currents at the stator of the motor are quite very well for both inverter, as you can see from the result, is suffer from the CMV problem as mentioned before. It's very important to reduce or eliminate this common mode voltage. So what about the grid connected inverter application? And you can see from the slide, when the common mode appear by the PWM switching action of the inverter, resulting in the leakage current or common mode current, CMC, as I said before, it affects to the protection. It affects to a protection tip. It affects to the protection tip. Sorry. Okay. It protects against its effect to the protection tip and safety for human due to the toss voltage and also the high dysfunction in light current, which look down the performance of the system. So once again, this slide shows the simulated result of the common mode and leakage current for both connected inverter with the power factor control application from the unity power factor, leading and lagging power factor control. Although the CMV and leakage current of the T-level inverter are lower than the 2-level inverter in terms of the magnitude, both value do not meet the international standard. It needs to be addressed them. The big question is how to do that to eliminate them. So this slide showed more detail regarding the common mode voltage and the leakage current waveform from generate from the Git Connect application from both inverter. Moving on to the next slide. In next slide, I would like to promote the new topology for three-level inverter, namely 12-switch inverter, hereby call it the B12 inverter. So what is the highlight of this topology? It can reduce the passive power switch when compared with the conventional ones, whereas the waveform quality at the output side inverter, the DC utilization and the common mode voltage are the same as the conventional three-level inverter, NPC inverter, and T-type inverter. You can see the particle circuit diagram for the new topology on the table from the right-hand side. Of course, what is the big challenging for this topology? Now, this slide shows you the basic concept in terms of the switching state PONs, which can generate the three-level pole voltage as same as the conventional three-level inverter. And the new stationary voltage vector as shown on the right-hand side in line with the voltage vector table. For the first challenging, how to develop the PWM strategy for this topology based on the SVM technique to meet the high DC utilization and waveform quality. Sorry. So here is the steps implement for SVM algorithm for B12 inverter. There are 4 steps which can develop the same as the standard SVM of the two-level inverter. It's very simple to implement. Unfortunately, I don't want to talk in the detail of this algorithm. So move on to the next slide. To clarify the proposed new SVM algorithm here, shows some simulated results in terms of pole voltage, line-to-line voltage, and common mode waveform from the top to bottom for the 7 and 5 switching voltage vector sequence or continuous and discontinuous PWM technique at the low to full modulations index from all results, which can confirm the functionalities in the practice. Once again, this simulated result of the FG of the output voltage for proposed new SVM methods compared to existing NPC and T-type inverter in function of the varying the modulation index as shown in the figures. The DC utilization and the output waveform quality are quite very well agree with the conventional ones. This is confirmed the performance of the proposed inverter with the new SVM scheme. So I would like you to think about the second challenge regarding how to eliminate the CMV based on B12 inverter with the SVM algorithm. That is the second challenge for eliminating the main problem of the CMV. So according to the relationship between the voltage vector as shown from the table and their CMV, and the spectral diagram here, which can use only 6 active and 2 zero voltage vector to synthesize the SVM scheme as shown from the diagram on the right hand side. As a result, the output electrolyte voltage can be effectively eliminate the CMV. This modulates it very simple and no need of the special algorithm and any additional hardware for the filter. That is the benefits of the post PWM. Once again, this slide shows the step implements with look like the standard algorithm as said before. There are the same 4 steps to implement for SVM algorithm to eliminate the common mode voltage as I said before. So to confirm the CMV eliminations based on the proposed concept, the picture presented here to compare the pole voltage and electrolyte voltage and its phenomenon and the CMV waveform with the varying the modulation index from all waveform from the top to bottom. For the proposed PWM with CMV elimination, it can eliminate the CMV when compared with the practical SVM algorithm. This is the active for neither the motor drive applications and the git interfacing application. So okay, again, this slide shows the performance evaluation about for the git interfacing application with the power factor control. In the simulation itself with the at post PWM can be kept constant. The CMV and cancel the leakage current for the OR-gate, the first section for the unity power factor control, and the other for the least and lag power factor control. You can see here, it can keep constant of the CMV and cancel the leakage current for the interfacing application based on B12 inverter. So in the end, for the second topic for this talk, I give you in the detail of the new topology, namely B12 inverter and some PWM strategy to eliminate the common mode voltage and eliminate the leakage current. Okay, and the simulation results give you in the possibility to practical in the real plant of the B12 inverter. So what's next? For the last topic, I would like to promote the new topology, namely 9-switch inverter. Actually, from the right hand side of the slide. Of course, it's different from the conversion to level and dual to level inverter for the single and dual rods respectively. The major benefit of this inverter is that it can reduce the active power switch and reduce losses in terms of conduction, and the switch loss lead to the high efficiency when compared with the dual two-level inverter. However, it's still the same problem with the CMV when the use of PWM switching action. Again, I would like you to think about the major challenging to eliminate the CMV for this topology. And here, in this slide shows some detail pertaining to the problem of the circulating currents in the conventional 9-switch inverter. I would like you to concentrate on the left box here. There are two kinds of circulating currents, cause and zero sequence circulating currents, which fall in the loop between the input side or common DC bus and the output side or common AC bus, causing in the dysfunction both output voltage and currents. It may decrease the system efficiency and stress on the active power switch of the 9-switch inverter. So the big question is how to eliminate the problems. So I would like to present the reconfigurations here of the 9-switch inverter with open-end AC load as shown in the picture. This scheme can eliminate the cause circulating currents, as I said before, with use the equivalent circuit here, as shown here to clarify the current flowing. It is remaining only the zero sequence circulating in the red box and the blue box. So based on the reconfiguration, as you can see from the left-hand side scheme, when compared with the existing method, this is the first time to approach the new topology for the AC motor drive application, such as the EV application, which is possible to eliminate the common mode voltage. That's the problem of the inverter. Again, the question is how to eliminate them. I would like you to concentrate on those blue and red box. And sorry. Okay. But again, I would like you to concentrate from this blue and red box, which are the series of the upper and lower inverter. For the blue box for the upper inverter and the red box for the lower inverter. If the COV of the upper and lower inverters are the same profiles for both the magnitude and the frequency, the differential CMV or DCMV will be effective zero. In these conditions, the zero sequence circulating is unable to flow in the system. Another series from this scheme is called an average CMV, ACMV. This average is not constant, resulting in the leakage, resulting in the induced leakage current or common mode current, CMC, which is still a problem for this topology. Therefore, the big main challenge is to find out the period method to overcome this problem. So for this slide, showed all detail to overcome the problem. The big question is how to eliminate them, how to do that. It is like give you in the detail for the a post PWM method to solve this problem. Okay, I would like you to concentrate on the toolbox from the slide. The first one is for the DCMV and ACMV, which depending on the pole voltage. And second one is both pole voltage for upper and lower inverter, which are depending on the PWM switching function. Of course, there are 27 possible switching state as shown from the diagram here. So, as I mentioned before, to confirm this idea by using the simulations, by using the simulation result. Here. For this result for the conventional 9-switch inverter with dual AC load, the UPS for the upper inverter and the AC motor drive for the lower inverter in line with the speed and torque waveform. It is important to note that both DCMV and ACMV are still appear with 4-step and 7-step level respectively, as shown in the last box. This is due to the use of 27 PWM switching state. Again, it suffers from the zero sequence leakage current. That's the main problem of the conventional 9-switch inverter with dual load UPS and motor drive application. To solve the DCMV and the ACMV problem, the new PWM method is proposed and presented here in this slide. This is very simple to implement in line with the technical SVM algorithm. This modulation is used only X PWM switching state, which does not contribute the DCMV, while the ACMV is able to reduce in the voltage state from 7 level to the 4 level. That's the main idea for improve the system by using only the post PWM algorithm. Once again, the use of the same step implementation of the SVM algorithm based on the post PWM to generate the PWM getting signal for the 9-switch with the open-end AC load as shown in the slide here. Now I will show you the result of the proposed system to verify the correctness and in practical possibility. In the case of steady state condition, there are two sections. The first is for input the waveform quality by using 7-segment PWM switching. And the second one is for reduction of the switching loss by using DC butt cam or 5-segment PWM switching technique as shown in the first column and the second column in the picture respectively. The DCMV for both methods are completely eliminated, and the AC DMVs are reduced significantly visit in agree with the theory. Finally, the dynamic test for the same condition of modulate are also present. You can see our waveform on the top to bottom from the right hand side. This is very well in line with the steady state condition. So it is possible to effective for the AC motor drive applications such as electric vehicle application. In the end, for the last topic of the novel nice inverter with the opinions AC motor drive or opinions AC load. And this is the first time for propose the new topology. It is suitable for the AC motor drive. It can develop the new PWM concept based on the spherical theory to eliminate the common mode rotate. Remember, there are two common mode rotate for this strategy, DCMV and ACMV. This moderate approach can eliminate DCMV and reduce the ACMV significantly. To reduce the leakage current too. So I want to conclude again for my presentation today. Thank you very much. If you have any question, please contact me by email. Thank you very much.
Professor Yuthana for his great video presentation. If any audience have any question, you can leave your questions on the chat box and we will collect it with your corresponding email. We will send all to him to respond your question via email. And thank you. And now let's move to the last panelist speaker of the RI Scare C 2011 and 2021. Sorry.
Okay, the first panelist speaker is Dr. Vilaiphon Chetanachan. She's graduated her PhD degree in organic chemistry from University of Cincinnati, USA. She has also completed Harvard Business School's Advanced Management Program, Strategic R&D Management by INSEAD, Management Development Program by Wharton School of Management and Leading Change and Organizational Renewal at Stanford School of Business. And currently, she has responsibility for the designs and implementation of corporate-wide innovation management system that includes the management of R&D process, project portfolio, research financing, return monitoring, intellectual properties, and alliance development. So it is such a great pleasure for all of us to hear what she will be sharing us from what she have done and what she have learned from her career and experiences in the topic of innovation accelerator, deep science and tech. Okay, and everyone, please join me to welcome Dr. Vilaiphon Chetanachan, Principal Innovation Advisor Office of the President and CEO, Siam Cement Group, SCG, Thailand. Please join me. Welcome, Dr. Vilaiphon.
Have you hear me now? Okay, great. Thank you very much for a nice introduction. First of all, right now I'm act as an advisor. Okay, I'm not full-time anymore. Okay. it's my great honor to share you about what we have done. So could you start with the first slide, please? Have you shared the first slide? Okay. Okay. Everybody see it now, right? Okay, good. Okay. First, next, please. Okay. First of all, I would like to make sure that all of us know the same thing. My question is, what is innovation? People will also think that they just invent something new, but actually invent something new is only invention. But to find the way to make product, service, or solution, and then have a value in it, that's innovation. So innovation actually is invention plus commercialization. Next, please. To be able to commercialize the product and service, the most important thing is we have to do feasibility study. And then before we do feasibility study, the most important thing is we have to select the right topic. Okay, the right topic can come from what is the world problem right now. So, for example, COVID-19 and health related issue, environmental issue. What are the mega trends right now? The mega trend is the aging people, the aging population will be increased. And then after we select the right topic that can solve world problems, then we will start to do feasibility study. Okay, next, please. So it composed of 3 areas. First is market feasibility, second technology feasibility, and then the third one is financial feasibility. Next, please. Okay. So when we select the right topic, we always have to ask first, who will buy your product, service, or solution, and how big is the market? Is the market is too small and is only few people can use your innovation? That's not a good starting. But if the market is very big and it has a potential to grow, and then also so many people would like to buy your product, then that's a good starting. Okay, next, please. And then we come to the technology phase. Very important that people will think that, oh, it's a huge market, we would like to do it, but do we have capability to do it? And 2 questions that we have to always ask. The first one, if we're going to do this, are we going to have the cost better than the other? What about our cost competitiveness? The second is, who is going to produce your product or your new product? Okay, so these 2 are very important. So first is how big is the market. Second is who is going to produce it, and then the cost. Whether the cost, for example, if your cost is more than 20% of the product that's sold in the market right now, most likely that you cannot compete in the market. Okay. The third one, if the market is phase, financial phase, please go to the next one. Next slide, financial phase, please. Okay. If the market is big and then your cost is competitive, most likely your financial phase will look good, which means that you have a good revenue and you have good margin. So that's a good starting for basic feasibility. Then we go to do the detail phase. If the detail feasibility and then by using worst case scenario and it still look good, then we will start to do research. So the way that we do, because we are in industry sector, so we always do paperwork as a feasibility before we start to do research to make sure that our project can go to commercialization. And even that, let me state that, even that many times that it will not go according to feasibility, we still have to share, but at least we will cut off all the project or cut out of the project that doesn't look good on the paper from feasibility. Next, please. These are some of the projects that I will show. The first one is dental series. Dental series, we have dental plaster, we have denture, and then we have dental cement as a series. Why we have to do this? First, Thailand keep on importing dental related product, more than 3,000 million baht, up to 6,000 million baht per year. The second is we found the white space that in this industry, there is no antimicrobial effect, which the doctor, the dentist would like to have. So the dentist and the technician will get infection from all those products. And the third one is we have the cement based knowledge. So we can increase the value of cement based knowledge. Okay. And by doing this, we only know the cement related industry, but for the dental related, we doesn't have that capability. So we work with dental Mahidol University Dental School. Okay. And also we work with the trader DKHS who ranked number one, 50% of market share in the world. Okay, and we got a set award of from this project. Next, please. The second one, for example, it's IoT implementation for industrial solution. Why we have to do this? Because we have silo, like 4,000 silo around Bangkok and suburb area. And then we have to measure what is left in the silo every morning, and then call back to the office and tell the office to send the cement to fill in those silo that's almost empty. Why this is very good? And then we got the Intel award. Okay, because this gives a better inventory management at real time, which means that once we know what is left, and then we know exactly where to transport those cement into what area that have those silo, and then we can know how much we have to produce, and then we know how much raw material that we have to prepare. So it is it will give us the effective supply chain and logistic planning. Okay, next, please. These are some examples of turn waste into value by burning coal to give energy. We have fly ash and bottom ash, and as you know, normally people will use fly ash and bottom ash for road construction, for Kyoto Kansai Airport, for example. Okay, and we already have the construction business at SCG, so we using fly ash and bottom ash, which is waste from burning coal and turn into brick. But it has to be a smarter brick than conventional brick. So it have a higher strength than conventional brick. It has a better heat insulation, and also it has a good fire resistance. Next, please. This is another one talking about saving energy. Normally in the petrochemical industry, refinery industry, and ceramic industry always have furnace, which use a very, very high temperature. And once only 1 or 2 degree or 1 or 2% of energy loss, that will cost a lot of money already. So we developed the furnace coating, which can save energy 2 to 6%. And we launched it in Southeast Asia. Our customer, including Korea and Japan also, not just Thailand. Next, please. This is an example of the concrete fabric, which from our cement know-how. Okay, so I think you remember the 13 wild boar team rescue in Tham Luang Cave in Thailand in 2018. It's the team got a problem to pump water out from the cave, because when you pump the water out from the cave, the water will go down to the soil and then back to the cave again. That's why they cannot reduce the water in the cave at the beginning. And then we use concrete fabric to transport water out of the cave. That's why this is the reason, one of the reasons that we can help to save the wild boar team. And why this technology is good? Because normally the reservoir in Thailand always use, or even golf course, for the reservoir, they use the plastic bag, the plastic. And then to steam the plastic, you have to use heat, and it's difficult. But this one, you don't need to use the heat, just lay down the concrete fabric on top of each other, and then it's connect by itself. So it's very easy, very simple, and too expensive. Okay, next piece. So I mentioned the conventional products that we have developed in the past, but as we know that there is always change all the time, change and disruption all the time. So next I'm going to talk about foresight and strategic management. Next, please. I developed this one like 10 years ago. Okay, we are looking at the global megatrends first, and then what are the global megatrends that we can capture 10 years ago? For example, digital age. Now people already realize, but develop this. We formulate this one like 10 years ago. The second one is environmental still exists, climate change, economic growth in this region. Okay, and then people. What about the people? People would like to have good health. So we think that healthy is a new luxury. And last but not least, but sustainability. People are looking more and more for sustainability. Next, please. Okay, so we come up to be 3 areas that we would like to focus. Like I mentioned to you, this is 10 years ago. The reason that I have to talk in the past is mean that if we do it well, if we did it well, it will pay back now, which is, I'm going to say that we did it well. So it's pay back now, because the area that we said that is going to be new growth area 10 years ago are 3 areas: sensor and IoT, well-being, and clean tech. Next, please. And then we have to look what are the common across industry. Okay, as you know that customer has more demand and demand. For example, if we want something, we want it now. So it means that not just we have the product in the stock, but we also have a good delivery service. We also have a good IT system like e-commerce. Okay, so digital is not only the key enabler anymore, but digital is very important for our business. Okay, and once there are so many people think that okay, this company sell a lot of this one. It's so we start to have more and more competitor, and then we get less and less margin, and there are disruption as we know all the time. Okay, complexity of the business come along, and automation, more and more automation that we need. So this, like I said, we developed this like 10 years ago, and it still exists. Okay, next, please. Next, please. So we saw the technology disruption. I will not talk much about this, because I think all of us know already about Airbnb disrupt hotel, Amazon disrupt many things like online video industry, movie industry, even now, even pharma industry. Okay, next, please. Why I like this company so much? Because when I got a training at Stanford, okay, Stanford said that Amazon is a very customer-centric companies. And what Jeff Bezos says, I would like to focus only 2 slides on the top, okay? He said that, I know that, he said that, I know our customer want low price. Is that true? Okay, luxury goods may be able to sell and may make a lot of profit, but majority of the people or the customers still want low price, fast delivery. If people want it, they want it now. And a vast selection, which means that not just one item, but like clothes, so many selections, so many variety, for example. So please remember these 3 words. Very important, okay? Customer want low price, fast delivery, and a vast selection. So he said that I know that is going to be true 10 years from now. When you have something that you know is true, even over the long term, you can afford to put a lot of energy into it. That's why Amazon keep on putting a lot of effort in these 3 areas. And look at the second slide on the right. Okay. Remember those 3 words. Okay. And then people want low price, so Amazon must have lower cost structure of everything. Lower cost structure of everything. So once Amazon have lower cost structure of everything, Amazon can lower the price. And then once Amazon can lower the price, Amazon can attract more customer and then give good customer experience, very easy to access, low price. And then once customer have good experience, people will talk, people will communicate. Amazon will increase the traffic on the site, which means that many people will come in and click and buy, okay? And then Amazon will have increased number of sellers. And then, so this product is good. A lot of people want it. Increased selection of goods. Remember what Jeff said, a vast selection. So he increased selection of goods and then increase of sale. Okay. And then come back to lower cost structure. So this is very genius in my opinion. If anyone can do innovation like this, then they're going to win in the market or in the industry, or even not related to industry at all, but they can serve, for example, like in the government sector, they serve the people in their country. They make they develop their knowledge and then become know-how and become the product or service to their country. People are going to use more if they can follow this guideline. Next, please. Remember, I told you the 3 areas that SCG will focus. That's 10 years ago. And then we come up to be innovation for health related. We come up to be innovation for better living. Next, please. You can see that these that I mentioned from past to future already exists. It's not future anymore. For example, go to see doctor when sick, to be consult doctor to stay fit. Infectious disease, lifestyle disease. Actually, lifestyle disease has more and more, but nowadays we have to cope with COVID-19, which is infectious disease. And trial and error therapy become diagnostic and gene therapy. Okay, cost-based healthcare become value-based healthcare. For example, next, please. Okay, we are talking about sensor and IoT. So digital technology, SCG already provide many of these that I show in this slide. Digital technology will play more roles in the healthcare. For example, remote areas, healthcare developing, and also in developing country, smartphone enabled device, 24/7 monitoring, health monitoring. Okay, next please. I'm sorry, this slide, some of them are in Thai, but for the packaging business, they develop, for example, the first one is dissolving bag for laundry, especially for the big hospital. They have to face with clothes that have patient clothes that have all kind of disease, germs, bacteria. So this one will help the hospital staff not to get infected. The second one is, for example, green carton. We use less fiber to so we can preserve more trees. Next slide, please. Okay, and this one, I think everybody in Thailand know about this. The first one is the bed, which make from carton. Actually, SCG donate a lot. I think almost 30,000 beds already around Thailand. Okay, the second one is for the toilet. Next, please. Next is also a product for to help COVID-19 or infectious disease. Okay, so it is like a negative and positive pressure room and isolation chamber. Next, please. And this one is the mask and also the spray. Next, please. This one is very important, and actually we help a lot of hospital in Thailand. Many hospitals already install modular ICU unit to battle COVID-19, which will be installed in only 10 days. So we start to work. The first hospital that we work with is Rajaviti Hospital. Next, please. Okay, and actually, if you go online to YouTube, you can check the video that show how this modular ICU unit built. Next, please. This one is very important that I would like to share to you, that to be able to achieve this kind of product, ICU, modular ICU unit, which can be installed only 10 days. We have to do what we know the best. So the red one is what we know the best, which is SCG know-how, okay? And then what we don't know the best, we have to find the one who know the best. And at that time, we work with Rajaviti Hospital. This hospital got a lot of patient who has COVID-19. That's why they know how to deal with it. So we work with them, and also SCG partner. So you can see that so many blocks, so many knowledge that we have to connect together until we get the product that can serve all the hospitals. Next, please. Now, talking back to what the Thai government or even other country government may have their new growth engine. For example, Thailand said that we have like 10S curve, starting from biofuel, next generation automotive, medical tourists, food for the future, smart electronic, okay? And also on the left, medical hubs, and then aerospace, agriculture, digital economy, automation. These are the new S-curve that the government forecast. I think that you can do research related to this. But like I said, next please, before you do any kind of research, you have to start with selecting the right topic that I mentioned before, okay? And then do the feasibilities before you do the research. Otherwise, your research will not get into innovation. Gonna be only invention and nobody use it, or nobody can use it because maybe only few people can use it, or maybe that kind of knowledge is not related to what people want, or the cost structure is too expensive. They buy it less expensive than we develop. So please make sure that you select the right topic and do a feasibility study. Next, please. Okay. There are so many tools that you can use to do innovation. For example, the design thinking process of Stanford D School. Next, please. You can develop the business model canvas to see who is the key partner, what are the key activities that you will do, what are the value proposition of your product service solution. Next, please. Now I come to the accelerator, and it's going to be only 3 slides left. Okay, why I have to talk about those before a lot? Because if you didn't do those before, then you have nothing to accelerate, which means that 99% of the project or of the research that you do in the past, or you did in the past, cannot really implement to be a product or service or solution, because the cost is not competitive, because the market is too small, because those products are too complicated. Okay, so what is an innovation accelerator? The point is a program to de-risk your innovation. Okay, and you will develop, test, and grow, and bring new product or service to the market. Next, please. Okay, so when they run innovation accelerator, where they focus on 3 areas. What is the business impact? What is the customer insight? And then capability building of your team. Next, please. Okay, and then the journey of the accelerator, how it's work. First one is scope the challenge and set up the team for success. Second one is explore and validate the customer problem. This is very important, because if you didn't get the right customer problem, the customer have no willing to buy, willing to pay, then you cannot sell your product. The third one is prototype and test multiple solution, not just one solution, multiple solution, because some of them may not work. The fourth one is define and test a sustainable business model to make sure that this business will sustain, not just sell 1 or 2 years and then it's expired. The fifth one is build and go to market plan. Okay, to make sure that your product service solution that you develop will go to real market and have real value, real income, real return. Okay, thank you very much for your kind attention. And if you have any question, please feel free to ask. Okay.
So thank you, Dr. Vilaiporn Chetanajan, so much for the excellent talk. Any question from the audience, please turn on the microphones and ask Dr. Vilaiporn directly. Or if you have any question and you cannot turn on the microphone, feel free to type your question in the chat box, and then I would grab your question and ask to Dr. Vilaiporn.
Any question?
I think Professor Somrek already raised up his hand, so please wait a little bit. The system might be delayed. Let me see.
Hello?
Hello,
Yes,
you can hear
okay.
me now?
Yeah.
Okay, thank you very much, Dr. Vilaipon. We are very happy that you accept our invitation to give a talk here, because we are now also starting to make a kind of acceleration platform. And I want to thank you very much for sharing us our idea to make a plan for this. And I think for the acceleration platform is really interesting, because the nature of the lecturers is to do a kind like a curiosity-based research. They have their own idea in something, and they would like to do a basic research. And this, I think, this is the nature of many professors. But anyway, if you like to look for the commercialization, do you have any suggestion that we have to give our lecturers some more idea about acceleration platform idea, that we have to think about the market or the facility first, or we leave them like that, but we look for some group of people who can make a good deal in business, and this group of people will look for the products in the university and try to negotiate or deal with the business. Do you have any suggestion for this?
Okay, in my opinion, Thai people and the country are not rich. We have limited resource. Resource mean people and money. Okay. So in my opinion, if any professor would like to do something based on their curiosity, can they combine with what Thailand needs? Can they combine with Thailand needs? So the money that put into research, at least maybe, or will be able to solve some of the Thailand problem, some of the farmer, some of the patient, okay, some of the environment. If it is related to those, in my opinion, like I mentioned before, in the governmental sector, they will not think about product, service, solution. That's try to be sale, but at least think about product, service, solution that can help Thai people. And then those kind of research will be useful, because frankly speaking, I saw so many research, so many people that already expired, because the technology nowadays is so fast, and then your research already expired within some certain years. Nobody gonna even pick up and read it. Would you like to do some research that people in Thailand will have benefit from it, from your knowledge, from your curiosity? I would suggest that way. Okay. And the other thing, if some of the professors already would like to solve some of Thailand problem, already would like to develop some products that Thai people can be used, and then start accelerate from that, and make sure that they do feasibility. Otherwise, many times that I am in many committee, at the end of the day, they don't know where to produce, who is going to be manufacturer, and also their cost is too expensive. Nobody would like to license or buy their technology. Okay, so it's not useful again if you didn't do the feasibility. So I answer both of your questions. Okay, thank you.
Thank you very much. And we will we are now trying to do in this way. Also, we try to ask the lecturers to think about some related problems. The topic should be related to the Thailand's problem or Thailand's pain point. And then we will try to take this idea for granting in our universities. And
that's good.
And
Thank
now
you.
And I also see Mr. President is also with us. I'm not so sure if Mr. President is also in the Zoom. Mr. President, you like to say hello to Dr. Vilaipon? I'm not so sure if you are present here.
Okay, anyway, that's fine. Thank you very much.
You're welcome. Any question?
Sure, Dr. Vilaypon, you got one question from the chat box. Could you
Okay.
mention a bit about licensing process when you deal with research invention with Mahidol University?
Actually, we discussed this from day one. Okay, because I think Mahidol University is at that time, Professor Pasvik, you may know, he's the dean of the dentist school. What he said to me, I feel very, very happy and very thankful for his answer. He said that at that time he don't spend money to do research, but if those money will go into commercialization, I would like to support, because it means that the research end game of the research can be used by the people. So he supports it a lot. So we talk about this, and actually Mahidol did not require that much, because Mahidol think for the benefit of Thai people. So it's not too difficult to be discussed about this. Okay, thank you.
Okay, thank you. So I think
I have one question.
okay, sure.
Okay, please.
Just so
Please.
you mentioned about that when the lecturer in university or the academic career, academic field have to do the research. So you mentioned that all the research has been coupling with the techno-economic feasibility or analysis, right, in order to commercialize the process or technology. And I would like to know that how to say it, like normally in the techno-economic assessment of the process is not just only give you or provide you just some information for the decision making for the business, and then I don't know if in the private sector you are going to pick up this process to for the pilot scale or for the commercialize after this after seeing the information from the research.
Let me repeat your question. Okay, whether we will do the feasibility or what?
Yes.
Okay, as I mentioned to you before, what we did in the past, we always do feasibility, market, technology, and financial before we start to do the projects. For example, we may have 10 projects, and we did our feasibility, and we may find out only 2 projects are interesting, which means that we have a chance to win, which means that we have a chance to have a good sale, we have a chance to have some margin. Okay, after we select those 2 projects that most likely we're gonna win, and then we start to do not just research, but we start to think about who is going to be our partner, like for dental series projects, because to develop, or even the modular ICU unit, to develop something, we may not have those all of those capabilities. So we start to think who is going to help us to do those. Okay, and then we discuss with those people, with those university, with those hospital, with those institute, and then come up with the framework of the, we call it action plan of what are we going to do at what timeline. If you think about COVID-19 is last year, right? About March. That's actually even before last year, but in Thailand, we realized that it gave a lot of problem to Thai people around March. We start to discuss about this. but at that time we trying to find high pressure what is that high pressure that give oxygen to people. I forgot the word already. Okay, at that time we did not think about modular ICU unit, but by time, and then there is no beds left, there is no negative pressure room left at the hospital. We start to think about it, and we develop very quick by the help of the Lachiviti Hospital and our partner, and then come up to be a solution that we can draft to get approval from the doctor, from the hospital, and then finally start to build like one small unit first before like 10 beds, maybe I could not remember now, 2 beds or 3 beds, and then test whether it's work or not. And then once we fill up all the gap, all the mistake, and then we finally can come up to build 10 beds modular ICU unit. So my point is we have to do feasibility study always before we start the project. For the COVID-19 projects, actually we didn't do much feasibility. The reason is because it's Thailand needs, and we know that SEG can help. That's why SEG just start to do it and get it out, and then make it quick to have product or service to solve Thailand. Okay, and it's really work. And as you know, for example, like the bed that make from carton, we have never sell it until now. We just donate it, and the good part is more and more people would like to donate with us, so we can have and even some people would like to donate the used carton, so we can use as raw material to produce it, to recycle it. Okay, and for the ICU modular unit is mainly also other people, other companies, the private sector help to donate, but not all the cost. We still absorb a lot. But this is what I said. Even we did not sell it, but it's for Thai people, to solve Thai people, to solve for Thailand. That's what in my opinion, what's the university research should focus on. Thank you.
Thank you.
All right, it's what a superb talk from Dr. Vilaiporn. Okay, so everyone, please join me to thank Dr. Vilaiporn one more time. And on the behalf of KMUTNB, I2C committee, and all of us, we would like to thank all the plenary speakers for sharing us their knowledge, experiences, and also future trend. And I think we all got some scientific idea, including knowledge, to drive our research in the near future.
Thank you. So have a good day.
Thank you.
Bye now. Bye now. Okay, bye. Bye now. Okay.
So our virtual platform I2C 2021 does not finish yet, and it will enroll in the afternoon session, which composed of 4 parallel sessions, including innovation, sustainable science, innovative material engineering, and 2 innovative electricals and electronics. The link for joining the afternoon session are provided in the chat box and our conference website. Finally, we are hoping you to enjoy your lunch and enjoy a great conference.
So ขอบคุณค่ะ สวัสดีค่ะ
นะคะเป็นตัวแทนกลุ่ม Crispy Egg ไข่ขาวอบกรอบจากมหาวิทยาลัยเทคโนโลยีพระจอมเกล้าพระนครเหนือค่ะผลิตภัณฑ์ของเรานะคะคือ Crispy Egg ไข่ขาวอบกรอบค่ะกลุ่มเป้าหมายก็คือกลุ่มผู้ป่วยนะคะที่เข้าสู่การบำบัดทดแทนไตโดยการฟอกเลือดด้วยเครื่องไตเทียมค่ะจุดเด่นของผลิตภัณฑ์ของเรานะคะคืออร่อยดีต่อสุขภาพมีโปรตีนสูงทานง่ายพกพาสะดวกทานได้ทุกที่ทุกเวลาราคาย่อมเยาเข้าถึงง่ายค่ะเพียงซองละ35 บาทค่ะโดยที่1ซองเนี่ยจะเทียบเท่ากับไข่ขาว1ฟองนะคะให้โปรตีน 3.5 ถึง 4 กรัมค่ะผลิตภัณฑ์ของเรานะคะจะแตกต่างจากท้องตลาดก็คือจะมีราคาที่ย่อมเยาวกว่านะคะโดยส่วนใหญ่ผลิตภัณฑ์ตามท้องตลาดเนี่ยจะมีราคาที่สูงนะคะเช่นอัลบูมินอัดเม็ดหรือว่าโปรตีนผงค่ะ
แผนการผลิตของเรานะคะภายใน1เดือนเราจะผลิตให้ได้ 1,500 ซองเพื่อวางจำหน่ายที่โรงพยาบาลเซนต์หลุยส์และเราจะผลิตให้ได้ทั้งหมด 5,000 ซองเพื่อวางจำหน่ายทั่วกรุงเทพและปริมณฑลมีมูลค่าอยู่ที่ 175,000 บาทโดยต้นทุนขนมของเรานะคะจะอยู่ที่ซองละ20 บาทเราจะมีการผลิตใหม่ทุกๆ10 วันเพื่อความสดใหม่ของขนมค่ะแผนการตลาดของเรานะคะเราจะมีการโปรโมททุกๆ3 เดือนที่โรงพยาบาลศูนย์ไตเทียมสื่อออนไลน์และงานอีเวนต์ตามห้างสรรพสินค้าค่ะเมื่อเข้าสู่ปีที่2นะคะเราจะมีการพัฒนาสูตรเพื่อเพิ่มสารอาหารและรสชาติให้ผู้บริโภคได้เลือกสรรหากต้องการติดต่อสอบถามเพิ่มเติมสามารถติดต่อได้ที่อีเมลด้านหน้านี้ได้เลยค่ะ
สวัสดีครับพวกเรา Firefighter Alert นะครับก็คืออุปกรณ์ติดตามตำแหน่งนักผจญเพลิงภายในอาคารแบบเรียลไทม์ครับ Firefighter Alert Box นะครับจะสามารถแสดงแผนผังภายในอาคารจากการเคลื่อนที่ของนักผจญเพลิงได้สามารถทดอุณหภูมิและป้องกันน้ำได้นะครับสามารถแสดงตำแหน่งได้แบบเรียลไทม์นะครับสามารถทำให้ทราบข้อมูลจะเป็นต่อการมีชีวิตอยู่ของนักผจญเพลิงได้นะครับเช่นปริมาณออกซิเจนหรือสัญญาณชีพครับและนี่นะครับก็คือโปรโตไทป์คอนเซปต์ของเรานะครับก็จะมีแบตเตอรี่ข้างในนะครับมีเสาสัญญาณที่จะส่งสัญญาณออกมาข้างนอกนะครับแล้วก็กล่องเนี่ยสามารถกันน้ำกันความชื้นได้นะครับแล้วก็มี IMU sensor นะครับแล้วก็มี microprocessor สำหรับประมวลผลข้างในครับและ target ของเรานะครับซองของเราจะขอแค่ 10% ของพี่ๆอาสากู้ภัยในกรุงเทพและปริมณฑลนะครับในส่วนคู่แข่งนะครับเราจะไม่มีคู่แข่งโดยตรงนะครับแต่จะเป็นอุปกรณ์ที่สามารถเทียบเคียงการใช้งานได้นะครับเช่น Apple AirTag นะครับจะใช้เทคโนโลยี Bluetooth 5.0 นะครับสามารถทำงานได้หลายอุปกรณ์มีความแม่นยำนะครับแต่ว่าไม่มีความคงทนไม่สามารถที่จะนำเข้าไปใช้ในพื้นที่ที่มีเขตเพลิงไหม้ได้นะครับ2นะครับก็คือ Manual Operation นะครับก็คือจะใช้คนในการบอกพิกัดนะครับจะสามารถทำงานได้หลายอุปกรณ์นะครับขึ้นอยู่กับคนนะครับแต่ไม่มีความแม่นยำเลยนะครับอันที่3นะครับ Firefighter Alert ของเราเนี่ยจะใช้คลื่นวิทยุความถี่ต่ำที่มีอำนาจทะลุทะลวงสูงนะครับจะสามารถทำงานได้หลายอุปกรณ์มีความแม่นยำนะครับแล้วก็มีความคงทนต่ออุณหภูมิขณะเกิดเพลิงไหม้ในอาคารครับสุดท้ายครับ Quick Alert Quick Rescue จากพวกเรา Firefighter Alert ครับสวัสดีครับสวัสดีครับพวกเรา Firefighter Alert นะครับ Firefighter Alert ก็คืออุปกรณ์ติดตามและบอกตำแหน่งนักผจญเพลิงภายในอาคารแบบเรียลไทม์นะครับซึ่งเราเกิดมาจากปัญหานี้ครับท่านคงเคยได้ยินข่าวไฟไหม้ที่หมู่บ้านกฤษณานครเขตทวีวัฒนาใช่ไหมครับและในเหตุการณ์นั้นเนี่ยก็ได้เกิดโศกนาฏกรรมนะครับมีผู้เสียชีวิตภายในบ้านนะครับและนอกจากนั้นนะครับส่งผลให้นักดับเพลิงนะครับที่เข้าไปช่วยเหลือนะครับเสียชีวิตอีก3ศพนะครับและอีกเหตุการณ์หนึ่งนะครับก็คือเหตุการณ์ไฟไหม้ธนาคารไทยพาณิชย์นะครับปีพุทธศักราช 2559 นะครับในเหตุการณ์นั้นเนี่ยมีผู้เสียชีวิต10ศพนะครับและนอกจากนั้นก็ยังมีทีมอาสากู้ภัยหรือนักผจญเพลิงนะครับเสียชีวิตในเหตุการณ์นั้นด้วยนะครับและสาเหตุหลักๆที่ทำให้ทีมนักผจญเพลิงนะครับเสียชีวิตนะครับก็คือทีมนักผจญเพลิงนะครับได้เกิดการพลัดหลงนะครับและไม่สามารถที่จะติดตามทีมไปได้เนื่องจากทัศนวิสัยแย่เนื่องจากควันไฟนะครับโดยที่นักผจญเพลิงพลัดหลงกับทีมและหมดสติไปนะครับก็จะทำให้เกิดความล่าช้าในการค้นหาผู้รอดชีวิตครับปริมาณออกซิเจนของเขาก็จะลดลงครับสูญเสียโอกาสในการปฐมพยาบาลเบื้องต้นไปนะครับเกิดความล่าช้าในการนำส่งโรงพยาบาลครับและสุดท้ายนะครับส่งผลให้โอกาสรอดชีวิตของเขาลดน้อยลงโดยข้อมูลอัคคีภัยประเทศไทยปี 2532 ถึง 2510 แสดงว่าแนวโน้มของการเกิดอัคคีภัยก็ยังเพิ่มสูงขึ้นตามใน4อย่างที่วงไว้นะครับและโดยเฉลี่ยนะครับ30 ปีที่ผ่านมามีเหตุการณ์เพลิงไหม้นะครับเกิดขึ้นประมาณ 58,000 ครั้งโดยเฉลี่ยเกิดขึ้นปีละ 2,000 ครั้งซึ่งหมายความว่าแต่ละวันจะมีเหตุเพลิงไหม้ถึง56พื้นที่นะครับซึ่งเป็นจำนวนที่มากนะครับแล้วก็ก่อให้เกิดความเสียหายอย่างนับไม่ถ้วนเลยทีเดียวเราจึงได้ลงพื้นที่ไปหาชมรมอาสาสมัครบรรเทาสาธารณภัยฐานดึงส่วนนะครับจังหวัดนนทบุรีได้ไปทำการสัมภาษณ์นะครับสอบถามนะครับแล้วก็สังเกตการทำงานของพี่ๆเขานะครับจนเราตกผลึกมาเป็น Firefighter Alert Box นะครับก็คือกล่องนะครับที่สามารถแสดงแผนผังภายในอาคารนะครับจากการเคลื่อนที่ของนักผจญเพลิงได้นะครับกล่องเนี่ยสามารถทนอุณหภูมิสูงและสามารถป้องกันน้ำได้สามารถแสดงตำแหน่งแบบเรียลไทม์ ได้นะสามารถทำให้ทราบข้อมูลที่จำเป็นในการมีชีวิตอยู่ของนักผจญเพลิงครับเช่นปริมาณออกซิเจนนะครับหรือสัญญาณชีพโดยที่ตัวโปรโตไทป์ของเรานะครับในส่วนสีส้มเนี่ยก็จะเป็นตัวกล่องอุปกรณ์ของเรานะครับก็จะมีสวิตช์ Emergency นะครับสามารถกดเมื่อต้องการขอความช่วยเหลือได้นะครับแล้วก็จะมีเซ็นเซอร์วัดออกซิเจนในเลือดนะครับแล้วก็วัดฮาร์ทเรทได้นะครับแล้วก็จะมี IMU sensor ที่สามารถวัดการเคลื่อนที่ของนักผจญเพลิงได้นะครับและยังมีออกซิเจน pressure sensor นะครับที่สามารถวัดปริมาณออกซิเจนที่นักดับเพลิงมีอยู่ได้นะครับและระบบนะครับก็จะส่งข้อมูลผ่านทางคลื่นวิทยุความถี่ต่ำที่มีอำนาจทะลุทะลวงสูงนะครับมายังศูนย์คอมมานด์นะครับศูนย์คอมมานด์ก็จะรับข้อมูลนะครับแล้วก็เข้าตัวโปรแกรมนะครับประมวลผลนะครับเป็นเส้นทางการเคลื่อนที่ของทีมผจญเพลิงนะครับและเมื่อเกิดเหตุการณ์ที่นักผจญเพลิงเนี่ยเกิดการพลัดหลงเกิดขึ้นนะครับคอมมานด์นะครับก็จะสั่งให้หัวหน้าทีมนะครับรีบกลับไปทำการค้นหาช่วยเหลือนักผจญเพลิงที่พลัดหลงได้ครับทำให้สามารถช่วยเหลือนักผจญเพลิงที่พลัดหลงได้อย่างทันท่วงทีและเพิ่มโอกาสการรอดชีวิตให้นักผจญเพลิงได้ครับโดยคอสตรัคเจอร์เราก็มีค่าพัฒนาฮาร์ดแวร์ซอฟต์แวร์นะครับค่าดูแลระบบนะครับแล้วก็ขนาด Market Size ของเรานะครับแทมของเราเนี่ยก็จะมีจำนวนกู้ภัยทั่วประเทศไทยนะครับจำนวน 667,873 คนนะครับแล้วก็เราจะโฟกัสย่อยลงมานะครับที่ในกรุงเทพมหานครนะครับจำนวน 53,108 คนครับซอมของเรานะครับเราจะขอแค่ 15% นะครับของอาสากู้ภัยในกรุงเทพนะครับทั้งหมดจำนวน 7,967 คนนะครับเราจะขายอุปกรณ์ในราคา 3,500 บาทนะครับเราก็จะได้เงินทั้งหมด 27,881,700 บาทส่วน Channel ของเรานะครับก็จะมีทางด้านออนไซต์นะครับเราจะลงพื้นที่ไปแนะนำพี่อพปลนะครับพี่อาสากู้ภัยนะครับจุดต่างๆภายในกรุงเทพนะครับแล้วก็ส่วนออนไลน์นะครับก็จะมีทางโซเชียลมีเดียแล้วก็ทางเว็บไซต์ของเราครับส่วน Key Metric นะครับเราตั้งเป้าหมายว่าเราจะขายอุปกรณ์นะครับให้ได้50ตัวต่อ1เดือนครับแล้วก็เพิ่มขึ้นทุกๆเดือนนะครับดังนั้นนะครับเราจะเจอจุดคุ้มทุนที่เดือนที่4นะครับทำให้เรานะครับวางแผนในเฟสแรกนะครับว่าเราจะขายอุปกรณ์ทั้งหมด450ชิ้นภายใน12เดือนนะครับซึ่งเราจะได้เงินมาทั้งหมด 1.75 ล้านบาทนะครับลบคอสที่เราต้องลงทุนไปอีก 1.12 ล้านนะครับทำให้เราได้กำไรทั้งหมด 0.45 ล้านบาทนะครับหรือประมาณ 450,000 บาทนั่นเองนะครับแล้วก็เฟส2นะครับเป็นเฟสที่เราจะเน้นการขายให้มากขึ้นนะครับเพื่อที่จะมาชดเชยค่า development ในส่วนแรกนะครับที่เราขาดทุนไปและพาร์ทเนอร์ของเรานะครับก็มีศูนย์กู้ชีพนเรนทรโรงพยาบาลราชวิถีนะครับแล้วก็มีที่อาสากู้ภัยนะครับแยกปีวานนท์นะครับจังหวัดนนทบุรีและนอกจากนั้นนะครับก็มีพี่ชมรมอาสาสมัครบรรเทาสาธารณภัยฐานริมสวนจังหวัดนนทบุรีครับและนี่คือทีมของเรานะครับเราได้รับเกียรติจากผู้ช่วยศาสตราจารย์ดร.ชลการวงศ์ก่อทรัพย์นะครับมาเป็นอาจารย์ที่ปรึกษาของเรานะครับแล้วเราก็มีนายโอภาสโกพันธ์นะครับเป็น CEO and Programmer นะครับแล้วก็มีนายณัฐพงษ์แท้อื้อนะครับเป็น Product Design แล้วก็มีนายชนาทิพย์จงสุขสันติกุลนะครับเป็น Marketing ของเรานะครับสุดท้ายครับ Quick Alert Quick Rescue ครับจากพวกเรา Firefighter Alert ครับขอบคุณครับ
สวัสดีค่ะพวกเรานะคะเป็นตัวแทนกลุ่ม Crispy Egg ไข่ขาวอบกรอบจากมหาวิทยาลัยเทคโนโลยีพระจอมเกล้าพระนครเหนือค่ะผลิตภัณฑ์ของเรานะคะคือ Crispy Egg ไข่ขาวอบกรอบค่ะกลุ่มเป้าหมายก็คือกลุ่มผู้ป่วยนะคะที่เข้าสู่การบำบัดทดแทนไตโดยการฟอกเลือดด้วยเครื่องไตเทียมค่ะจุดเด่นของผลิตภัณฑ์ของเรานะคะคืออร่อยดีต่อสุขภาพมีโปรตีนสูงทานง่ายพกพาสะดวกทานได้ทุกที่ทุกเวลาราคาย่อมเยาเข้าถึงง่ายค่ะเพียงซองละ35 บาทค่ะโดยที่1ซองเนี่ยจะเทียบเท่ากับไข่ขาว1ฟองนะคะให้โปรตีน 3.5 ถึง 4 กรัมค่ะผลิตภัณฑ์ของเรานะคะจะแตกต่างจากท้องตลาดก็คือจะมีราคาที่ย่อมเยาวกว่านะคะโดยส่วนใหญ่ผลิตภัณฑ์ตามท้องตลาดเนี่ยจะมีราคาที่สูงนะคะเช่นอัลบูมินอัดเม็ดหรือว่าโปรตีนผงค่ะ
แผนการผลิตของเรานะคะภายใน1เดือนเราจะผลิตให้ได้ 1,500 ซองเพื่อวางจำหน่ายที่โรงพยาบาลเซนต์หลุยส์และเราจะผลิตให้ได้ทั้งหมด 5,000 ซองเพื่อวางจำหน่ายทั่วกรุงเทพและปริมณฑลมีมูลค่าอยู่ที่ 175,000 บาทโดยต้นทุนขนมของเรานะคะจะอยู่ที่ซองละ20 บาทเราจะมีการผลิตใหม่ทุกๆ10วันเพื่อความสดใหม่ของขนมค่ะแผนการตลาดของเรานะคะเราจะมีการโปรโมททุกๆ3เดือนที่โรงพยาบาลศูนย์ไตเทียมสื่อออนไลน์และงานอีเวนต์ตามห้างสรรพสินค้าค่ะเมื่อเข้าสู่ปีที่2นะคะเราจะมีการพัฒนาสูตรเพื่อเพิ่มสารอาหารและรสชาติให้ผู้บริโภคได้เลือกสรรหากต้องการติดต่อสอบถามเพิ่มเติมสามารถติดต่อได้ที่อีเมลด้านหน้านี้ได้เลยค่ะ
สวัสดีครับพวกเรา Firefighter Alert นะครับก็คืออุปกรณ์ติดตามตำแหน่งนักผจญเพลิงภายในอาคารแบบเรียลไทม์ครับ Firefighter Alert Box นะครับจะสามารถแสดงแผนผังภายในอาคารจากการเคลื่อนที่ของนักผจญเพลิงได้สามารถทดอุณหภูมิและป้องกันน้ำได้นะครับสามารถแสดงตำแหน่งได้แบบเรียลไทม์นะครับสามารถทำให้ทราบข้อมูลจะเป็นต่อการมีชีวิตอยู่ของนักผจญเพลิงได้นะครับเช่นปริมาณออกซิเจนหรือสัญญาณชีพครับ และนี่นะครับก็คือโปรโตไทป์คอนเซปต์ของเรานะครับก็จะมีแบตเตอรี่ข้างในนะครับมีเสาสัญญาณที่จะส่งสัญญาณออกมาข้างนอกนะครับแล้วก็กล่องเนี่ยสามารถกันน้ำกันความชื้นได้นะครับแล้วก็มี IMU sensor นะครับแล้วก็มี microprocessor สำหรับประมวลผลข้างในครับและ target ของเรานะครับซอมของเราจะขอแค่ 10% ของพี่ๆอาสากู้ภัยในกรุงเทพและปริมณฑลนะครับในส่วนคู่แข่งนะครับเราจะไม่มีคู่แข่งโดยตรงนะครับแต่จะเป็นอุปกรณ์ที่สามารถเทียบเคียงการใช้งานได้นะครับเช่น Apple AirTag นะครับจะใช้เทคโนโลยี Bluetooth 5.0 นะครับสามารถทำงานได้หลายอุปกรณ์มีความแม่นยำนะครับแต่ว่าไม่มีความคงทนไม่สามารถที่จะนำเข้าไปใช้ในพื้นที่ที่มีเขตเพลิงไหม้ได้นะครับ2นะครับก็คือ Manual Operation นะครับก็คือจะใช้คนในการบอกพิกัดนะครับจะสามารถทำงานได้หลายอุปกรณ์นะครับขึ้นอยู่กับคนนะครับแต่ไม่มีความแม่นยำเลยนะครับอันที่3นะครับ Firefighter Alert ของเราเนี่ยจะใช้คลื่นวิทยุความถี่ต่ำที่มีอำนาจทะลุทะลวงสูงนะครับจะสามารถทำงานได้หลายอุปกรณ์มีความแม่นยำนะครับแล้วก็มีความคงทนต่ออุณหภูมิขณะเกิดเพลิงไหม้ในอาคารครับสุดท้ายครับ Quick Alert Quick Rescue จากพวกเรา Firefighter Alert ครับสวัสดีครับสวัสดีครับพวกเรา Firefighter Alert นะครับ Firefighter Alert ก็คืออุปกรณ์ติดตามและบอกตำแหน่งนักผจญเพลิงภายในอาคารแบบเรียลไทม์นะครับซึ่งเราเกิดมาจากปัญหานี้ครับท่านคงเคยได้ยินข่าวไฟไหม้ที่หมู่บ้านกฤษณานครเขตทวีวัฒนาใช่ไหมครับและในเหตุการณ์นั้นเนี่ยก็ได้เกิดโศกนาฏกรรมนะครับมีผู้เสียชีวิตภายในบ้านนะครับและนอกจากนั้นนะครับส่งผลให้นักดับเพลิงนะครับที่เข้าไปช่วยเหลือนะครับเสียชีวิตอีก3ศพนะครับและอีกเหตุการณ์หนึ่งนะครับก็คือเหตุการณ์ไฟไหม้ธนาคารไทยพาณิชย์นะครับปีพุทธศักราช 2559 นะครับในเหตุการณ์นั้นเนี่ยมีผู้เสียชีวิต10ศพนะครับและนอกจากนั้นก็ยังมีทีมอาสากู้ภัยหรือนักผจญเพลิงนะครับเสียชีวิตในเหตุการณ์นั้นด้วยนะครับและสาเหตุหลักๆที่ทำให้ทีมนักผจญเพลิงนะครับเสียชีวิตนะครับก็คือทีมนักผจญเพลิงนะครับได้เกิดการพลัดหลงนะครับและไม่สามารถที่จะติดตามทีมไปได้เนื่องจากทัศนวิสัยแย่เนื่องจากควันไฟนะครับโดยที่นักผจญเพลิงพลัดหลงกับทีมและหมดสติไปนะครับก็จะทำให้เกิดความล่าช้าในการค้นหาผู้รอดชีวิตครับปริมาณออกซิเจนของเขาก็จะลดลงครับสูญเสียโอกาสในการปฐมพยาบาลเบื้องต้นไปนะครับเกิดความล่าช้าในการนำส่งโรงพยาบาลครับและสุดท้ายนะครับส่งผลให้โอกาสรอดชีวิตของเขาลดน้อยลงโดยข้อมูลอัคคีภัยประเทศไทยปี 2532 ถึง 2510 แสดงว่าแนวโน้มของการเกิดอัคคีภัยก็ยังเพิ่มสูงขึ้นตามในสี่เหลี่ยมที่วงไว้นะครับและโดยเฉลี่ยนะครับ30 ปีที่ผ่านมามีเหตุการณ์เพลิงไหม้นะครับเกิดขึ้นประมาณ 58,000 ครั้งโดยเฉลี่ยเกิดขึ้นปีละ 2,000 ครั้งซึ่งหมายความว่าแต่ละวันจะมีเหตุเพลิงไหม้ถึง56พื้นที่นะครับซึ่งเป็นจำนวนที่มากนะครับแล้วก็ก่อให้เกิดความเสียหายอย่างนับไม่ถ้วนเลยทีเดียวเราจึงได้ลงพื้นที่ไปหาชมรมอาสาสมัครบรรเทาสาธารณภัยฐานดึงส่วนนะครับจังหวัดนนทบุรีได้ไปทำการสัมภาษณ์นะครับสอบถามนะครับแล้วก็สังเกตการทำงานของพี่ๆเขานะครับจนเราตกผลึกมาเป็น Firefighter Alert Box นะครับก็คือกล่องนะครับที่สามารถแสดงแผนผังภายในอาคารนะครับจากการเคลื่อนที่ของนักผจญเพลิงได้นะครับกล่องเนี่ยสามารถทนอุณหภูมิสูงและสามารถป้องกันน้ำได้สามารถแสดงตำแหน่งแบบเรียลไทม์ได้นะสามารถทำให้ทราบข้อมูลที่จำเป็นในการมีชีวิตอยู่ของนักผจญเพลิงครับเช่นปริมาณออกซิเจนนะครับหรือสัญญาณชีพโดยที่ตัวโปรโตไทป์ของเรานะครับในส่วนสีส้มเนี่ยก็จะเป็นตัวกล่องอุปกรณ์ของเรานะครับก็จะมีสวิตช์ Emergency นะครับสามารถกดเมื่อต้องการขอความช่วยเหลือได้นะครับแล้วก็จะมีเซ็นเซอร์วัดออกซิเจนในเลือดนะครับแล้วก็วัดฮาร์ทเรทได้นะครับแล้วก็จะมี IMU sensor ที่สามารถวัดการเคลื่อนที่ของนักผจญเพลิงได้นะครับและยังมีออกซิเจนเพรสเชอร์เซนเซอร์นะครับที่สามารถวัดปริมาณออกซิเจนที่นักดับเพลิงมีอยู่ได้นะครับและระบบนะครับก็จะส่งข้อมูลผ่านทางคลื่นวิทยุความถี่ต่ำที่มีอำนาจทะลุทะลวงสูงนะครับมายังศูนย์คอมมานด์นะครับศูนย์คอมมานด์ก็จะรับข้อมูลนะครับแล้วก็เข้าตัวโปรแกรมนะครับประมวลผลนะครับเป็นเส้นทางการเคลื่อนที่ของทีมผจญเพลิงนะครับและเมื่อเกิดเหตุการณ์ที่นักผจญเพลิงเนี่ยเกิดการพลัดหลงเกิดขึ้นนะครับคอมมานด์นะครับก็จะสั่งให้หัวหน้าทีมนะครับรีบกลับไปทำการค้นหาช่วยเหลือนักผจญเพลิงที่พลัดหลงได้ครับทำให้สามารถช่วยเหลือนักผจญเพลิงที่พลัดหลงได้อย่างทันท่วงทีและเพิ่มโอกาสการรอดชีวิตให้นักผจญเพลิงได้ครับโดยคอสตรัคเจอร์เราก็มีค่าพัฒนาฮาร์ดแวร์ซอฟต์แวร์นะครับค่าดูแลระบบนะครับแล้วก็ขนาด Market Size ของเรานะครับแทมของเราเนี่ยก็จะมีจำนวนกู้ภัยทั่วประเทศไทยนะครับจำนวน 667,873 คนนะครับแล้วก็เราจะโฟกัสย่อยลงมานะครับที่ในกรุงเทพมหานครนะครับจำนวน 53,108 คนครับซอมของเรานะครับเราจะขอแค่ 15% นะครับของอาสากู้ภัยในกรุงเทพนะครับทั้งหมดจำนวน 7,967 คนนะครับเราจะขายอุปกรณ์ในราคา 3,500 บาทนะครับเราก็จะได้เงินทั้งหมด 27,881,700 บาทส่วน Channel ของเรานะครับก็จะมีทางด้านออนไซต์นะครับเราจะลงพื้นที่ไปแนะนำพี่อพปลนะครับพี่อาสากู้ภัยนะครับจุดต่างๆภายในกรุงเทพนะครับแล้วก็ส่วนออนไลน์นะครับก็จะมีทางโซเชียลมีเดียแล้วก็ทางเว็บไซต์ของเราครับส่วน Key Metric นะครับเราตั้งเป้าหมายว่าเราจะขายอุปกรณ์นะครับให้ได้50ตัวต่อ1เดือนครับแล้วก็เพิ่มขึ้นทุกๆเดือนนะครับดังนั้นนะครับเราจะเจอจุดคุ้มทุนที่เดือนที่4นะครับ ทำให้เรานะครับวางแผนในเฟสแรกนะครับว่าเราจะขายอุปกรณ์ทั้งหมด450ชิ้นภายใน12เดือนนะครับซึ่งเราจะได้เงินมาทั้งหมด 1.75 ล้านบาทนะครับลบคอสที่เราต้องลงทุนไปอีก 1.12 ล้านนะครับทำให้เราได้กำไรทั้งหมด 0.45 ล้านบาทนะครับหรือประมาณ 450,000 บาทนั่นเองนะครับแล้วก็เฟส2นะครับเป็นเฟสที่เราจะเน้นการขายให้มากขึ้นนะครับเพื่อที่จะมาชดเชยค่า development ในส่วนแรกนะครับที่เราขาดทุนไปและพาร์ทเนอร์ของเรานะครับก็มีศูนย์กู้ชีพนเรนทรโรงพยาบาลราชวิถีนะครับแล้วก็มีที่อาสากู้ภัยนะครับแยกติวานนท์นะครับจังหวัดนนทบุรีและนอกจากนั้นนะครับก็มีพี่ชมรมอาสาสมัครบรรเทาสาธารณภัยฐานริมสวนจังหวัดนนทบุรีครับและนี่คือทีมของเรานะครับเราได้รับเกียรติจากผู้ช่วยศาสตราจารย์ดร.ชลการวงกรทรัพย์นะครับมาเป็นอาจารย์ที่ปรึกษาของเรานะครับแล้วเราก็มีนายโอภาสโกพันธ์นะครับเป็น CEO and Programmer นะครับแล้วก็มีนายณัฐพงษ์แท้อื้อนะครับเป็น Product Design แล้วก็มีนายชนาทิพย์จงสุขสันติกุลนะครับเป็น Marketing ของเรานะครับสุดท้ายครับ Quick Alert Quick Rescue ครับจากพวกเรา Firefighter Alert ครับขอบคุณครับ
สวัสดีค่ะพวกเรานะคะเป็นตัวแทนกลุ่ม Crispy Egg ไข่ขาวอบกรอบจากมหาวิทยาลัยเทคโนโลยีพระจอมเกล้าพระนครเหนือค่ะผลิตภัณฑ์ของเรานะคะคือ Crispy Egg ไข่ขาวอบกรอบค่ะกลุ่มเป้าหมายก็คือกลุ่มผู้ป่วยนะคะที่เข้าสู่การบำบัดทดแทนไตโดยการฟอกเลือดด้วยเครื่องไตเทียมค่ะจุดเด่นของผลิตภัณฑ์ของเรานะคะคืออร่อยดีต่อสุขภาพมีโปรตีนสูงทานง่ายพกพาสะดวกทานได้ทุกที่ทุกเวลาราคาย่อมเยาเข้าถึงง่ายค่ะเพียงซองละ35 บาทค่ะโดยที่1ซองเนี่ยจะเทียบเท่ากับไข่ขาว1ฟองนะคะให้โปรตีน 3.5 ถึง 4 กรัมค่ะผลิตภัณฑ์ของเรานะคะจะแตกต่างจากท้องตลาดก็คือจะมีราคาที่ย่อมเยาวกว่านะคะโดยส่วนใหญ่ผลิตภัณฑ์ตามท้องตลาดเนี่ยจะมีราคาที่สูงนะคะเช่นอัลบูมินอัดเม็ดหรือว่าโปรตีนผงค่ะ
แผนการผลิตของเรานะคะภายใน1เดือนเราจะผลิตให้ได้ 1,500 ซองเพื่อวางจำหน่ายที่โรงพยาบาลเซนต์หลุยส์และเราจะผลิตให้ได้ทั้งหมด 5,000 ซองเพื่อวางจำหน่ายทั่วกรุงเทพและปริมณฑลมีมูลค่าอยู่ที่ 175,000 บาทโดยต้นทุนขนมของเรานะคะจะอยู่ที่ซองละ20 บาทเราจะมีการผลิตใหม่ทุกๆ10 วันเพื่อความสดใหม่ของขนมค่ะแผนการตลาดของเรานะคะเราจะมีการโปรโมททุกๆ3เดือนที่โรงพยาบาลศูนย์ไตเทียมสื่อออนไลน์และงานอีเวนต์ตามห้างสรรพสินค้าค่ะเมื่อเข้าสู่ปีที่2นะคะเราจะมีการพัฒนาสูตรเพื่อเพิ่มสารอาหารและรสชาติให้ผู้บริโภคได้เลือกสรรหากต้องการติดต่อสอบถามเพิ่มเติมสามารถติดต่อได้ที่อีเมลด้านหน้านี้ได้เลยค่ะ
สวัสดีครับพวกเรา Firefighter Alert นะครับก็คืออุปกรณ์ติดตามตำแหน่งนักผจญเพลิงภายในอาคารแบบเรียลไทม์ครับ Firefighter Alert Box นะครับจะสามารถแสดงแผนผังภายในอาคารจากการเคลื่อนที่ของนักผจญเพลิงได้สามารถทดอุณหภูมิและป้องกันน้ำได้นะครับสามารถแสดงตำแหน่งได้แบบเรียลไทม์นะครับสามารถทำให้ทราบข้อมูลจะเป็นต่อการมีชีวิตอยู่ของนักผจญเพลิงได้นะครับเช่นปริมาณออกซิเจนหรือสัญญาณชีพครับและนี่นะครับก็คือโปรโตไทป์คอนเซ็ปต์ของเรานะครับก็จะมีแบตเตอรี่ข้างในนะครับมีเสาสัญญาณที่จะส่งสัญญาณออกมาข้างนอกนะครับแล้วก็กล่องเนี่ยสามารถกันน้ำกันความชื้นได้นะครับแล้วก็มี IMU sensor นะครับแล้วก็มี microprocessor สำหรับประมวลผลข้างในครับและ target ของเรานะครับซองของเราจะขอแค่ 10% ของพี่ๆอาสากู้ภัยในกรุงเทพและปริมณฑลนะครับในส่วนคู่แข่งนะครับเราจะไม่มีคู่แข่งโดยตรงนะครับแต่จะเป็นอุปกรณ์ที่สามารถเทียบเคียงการใช้งานได้นะครับเช่น Apple AirTag นะครับจะใช้เทคโนโลยี Bluetooth 5.0 นะครับสามารถทำงานได้หลายอุปกรณ์มีความแม่นยำนะครับแต่ว่าไม่มีความคงทนไม่สามารถที่จะนำเข้าไปใช้ในพื้นที่ที่มีเขตเพลิงไหม้ได้นะครับ2นะครับก็คือ Manual Operation นะครับก็คือจะใช้คนในการบอกพิกัดนะครับจะสามารถทำงานได้หลายอุปกรณ์นะครับขึ้นอยู่กับคนนะครับแต่ไม่มีความแม่นยำเลยนะครับอันที่3นะครับ Firefighter Alert ของเราเนี่ยจะใช้คลื่นวิทยุความถี่ต่ำที่มีอำนาจทะลุทะลวงสูงนะครับจะสามารถทำงานได้หลายอุปกรณ์มีความแม่นยำนะครับแล้วก็มีความคงทนต่ออุณหภูมิขณะเกิดเพลิงไหม้ในอาคารครับสุดท้ายครับ Quick Alert Quick Rescue จากพวกเรา Firefighter Alert ครับสวัสดีครับสวัสดีครับพวกเรา Firefighter Alert นะครับ Firefighter Alert ก็คืออุปกรณ์ติดตามและบอกตำแหน่งนักผจญเพลิงภายในอาคารแบบเรียลไทม์นะครับซึ่งเราเกิดมาจากปัญหานี้ครับท่านคงเคยได้ยินข่าวไฟไหม้ที่หมู่บ้านกฤษณานครเขตทวีวัฒนาใช่ไหมครับและในเหตุการณ์นั้นเนี่ยก็ได้เกิดโศกนาฏกรรมนะครับมีผู้เสียชีวิตภายในบ้านนะครับและนอกจากนั้นนะครับส่งผลให้นักดับเพลิงนะครับที่เข้าไปช่วยเหลือนะครับเสียชีวิตอีก3ศพนะครับและอีกเหตุการณ์หนึ่งนะครับก็คือเหตุการณ์ไฟไหม้ธนาคารไทยพาณิชย์นะครับปีพุทธศักราช 2559 นะครับในเหตุการณ์นั้นเนี่ยมีผู้เสียชีวิต10ศพนะครับและนอกจากนั้นก็ยังมีทีมอาสากู้ภัยหรือนักผจญเพลิงนะครับเสียชีวิตในเหตุการณ์นั้นด้วยนะครับและสาเหตุหลักๆที่ทำให้ทีมนักผจญเพลิงนะครับเสียชีวิตนะครับก็คือทีมนักผจญเพลิงนะครับได้เกิดการพลัดหลงนะครับและไม่สามารถที่จะติดตามทีมไปได้เนื่องจาก ทัศนวิสัยแย่เนื่องจากควันไฟนะครับโดยที่นักผจญเพลิงพัดหลงกับทีมและหมดสติไปนะครับก็จะทำให้เกิดความล่าช้าในการค้นหาผู้รอดชีวิตครับปริมาณออกซิเจนของเขาก็จะลดลงครับสูญเสียโอกาสในการปฐมพยาบาลเบื้องต้นไปนะครับเกิดความล่าช้าในการนำส่งโรงพยาบาลครับและสุดท้ายนะครับส่งผลให้โอกาสรอดชีวิตของเขาลดน้อยลงโดยข้อมูลอัคคีภัยประเทศไทยปี 2532 ถึง 2510 แสดงว่าแนวโน้มของการเกิดอัคคีภัยก็ยังเพิ่มสูงขึ้นตามในสี่เหลี่ยมที่วงไว้นะครับและโดยเฉลี่ยนะครับ30 ปีที่ผ่านมามีเหตุการณ์เพลิงไหม้นะครับเกิดขึ้นประมาณ 58,000 ครั้งโดยเฉลี่ยเกิดขึ้นปีละ 2,000 ครั้งซึ่งหมายความว่าแต่ละวันจะมีเหตุเพลิงไหม้ถึง56พื้นที่นะครับซึ่งเป็นจำนวนที่มากนะครับแล้วก็ก่อให้เกิดความเสียหายอย่างนับไม่ถ้วนเลยทีเดียวเราจึงได้ลงพื้นที่ไปหาชมรมอาสาสมัครบรรเทาสาธารณภัยฐานดึงส่วนนะครับจังหวัดนนทบุรีได้ไปทำการสัมภาษณ์นะครับสอบถามนะครับแล้วก็สังเกตการทำงานของพี่ๆเขานะครับจนเราตกผลึกมาเป็น Firefighter Alert Box นะครับก็คือกล่องนะครับที่สามารถแสดงแผนผังภายในอาคารนะครับจากการเคลื่อนที่ของนักผจญเพลิงได้นะครับกล่องเนี่ยสามารถทนอุณหภูมิสูงและสามารถป้องกันน้ำได้สามารถแสดงตำแหน่งแบบเรียลไทม์ได้นะสามารถทำให้ทราบข้อมูลที่จำเป็นในการมีชีวิตอยู่ของนักผจญเพลิงครับเช่นปริมาณออกซิเจนนะครับหรือสัญญาณชีพโดยที่ตัวโปรโตไทป์ของเรานะครับในส่วนนี้ส้มเนี่ยก็จะเป็นตัวกล่องอุปกรณ์ของเรานะครับก็จะมีสวิตช์ Emergency นะครับสามารถกดเมื่อต้องการขอความช่วยเหลือได้นะครับแล้วก็จะมีเซ็นเซอร์วัดออกซิเจนในเลือดนะครับแล้วก็วัด heart rate ได้นะครับแล้วก็จะมี IMU sensor ที่สามารถวัดการเคลื่อนที่ของนักผจญเพลิงได้นะครับและยังมี oxygen pressure sensor นะครับที่สามารถวัดปริมาณออกซิเจนที่นักดับเพลิงมีอยู่ได้นะครับและระบบนะครับก็จะส่งข้อมูลผ่านทางคลื่นวิทยุความถี่ต่ำที่มีอำนาจทะลุทะลวงสูงนะครับมายังศูนย์คอมมานด์นะครับศูนย์คอมมานด์ก็จะรับข้อมูลนะครับแล้วก็เข้าตัวโปรแกรมนะครับประมวลผลนะครับเป็นเส้นทางการเคลื่อนที่ของทีมผจญเพลิงนะครับและเมื่อเกิดเหตุการณ์ที่นักผจญเพลิงเนี่ยเกิดการพลัดหลงเกิดขึ้นนะครับคอมมานด์นะครับก็จะสั่งให้หัวหน้าทีมนะครับรีบกลับไปทำการค้นหาช่วยเหลือนักผจญเพลิงที่พลัดหลงได้ครับทำให้สามารถช่วยเหลือนักผจญเพลิงที่พลัดหลงได้อย่างทันท่วงทีและเพิ่มโอกาสการรอดชีวิตให้นักผจญเพลิงได้ครับโดยคอสตรัคเจอร์เราก็มีค่าพัฒนาฮาร์ดแวร์ซอฟต์แวร์นะครับค่าดูแลระบบนะครับแล้วก็ขนาด Market Size ของเรานะครับแทมของเราเนี่ยก็จะมีจำนวนกู้ภัยทั่วประเทศไทยนะครับจำนวน 667,873 คนนะครับแล้วก็เราจะโฟกัสย่อยลงมานะครับที่ในกรุงเทพมหานครนะครับจำนวน 53,108 คนครับซอมของเรานะครับเราจะขอแค่ 15% นะครับของอาสากู้ภัยในกรุงเทพนะครับทั้งหมดจำนวน 7,967 คนนะครับเราจะขายอุปกรณ์ในราคา 3,500 บาทนะครับเราก็จะได้เงินทั้งหมด 27,881,700 บาทส่วน Channel ของเรานะครับก็จะมีทางด้านออนไซต์นะครับเราจะลงพื้นที่ไปแนะนำพี่อพปลนะครับพี่อาสากู้ภัยนะครับจุดต่างๆภายในกรุงเทพนะครับแล้วก็ส่วนออนไลน์นะครับก็จะมีทางโซเชียลมีเดียแล้วก็ทางเว็บไซต์ของเราครับส่วน Key Metric นะครับเราตั้งเป้าหมายว่าเราจะขายอุปกรณ์นะครับให้ได้50ตัวต่อ1เดือนครับแล้วก็เพิ่มขึ้นทุกๆเดือนนะครับดังนั้นนะครับเราจะเจอจุดคุ้มทุนที่เดือนที่4นะครับทำให้เรานะครับวางแผนในเฟสแรกนะครับว่าเราจะขายอุปกรณ์ทั้งหมด450ชิ้นภายใน12เดือนนะครับซึ่งเราจะได้เงินมาทั้งหมด 1.75 ล้านบาทนะครับลบคอสที่เราต้องลงทุนไปอีก1.12 ล้านนะครับทำให้เราได้กำไรทั้งหมด 0.45 ล้านบาทนะครับหรือประมาณ 450,000 บาทนั่นเองนะครับแล้วก็เฟส2นะครับเป็นเฟสที่เราจะเน้นการขายให้มากขึ้นนะครับเพื่อที่จะมาชดเชยค่า development ในส่วนแรกนะครับที่เราขาดทุนไปและพาร์ทเนอร์ของเรานะครับก็มีศูนย์กู้ชีพนเรนทรโรงพยาบาลราชวิถีนะครับแล้วก็มีพี่อาสากู้ภัยนะครับแยกติวานนท์นะครับจังหวัดนนทบุรีและนอกจากนั้นนะครับก็มีพี่ชมรมอาสาสมัครบรรเทาสาธารณภัยฐานริมสวนจังหวัดนนทบุรีครับและนี่คือทีมของเรานะครับเราได้รับเกียรติจากผู้ช่วยศาสตราจารย์ดร.ชลการวงกรทรัพย์นะครับมาเป็นอาจารย์ที่ปรึกษาของเรานะครับแล้วเราก็มีนายโอภาสโกพันธ์นะครับเป็น CEO and Programmer นะครับแล้วก็มีนายณัฐพงษ์แท้อื้อนะครับเป็น Product Design แล้วก็มีนายชนาทิพย์จงสุขสันติกุลนะครับเป็น Marketing ของเรานะครับสุดท้ายครับ Quick Alert Quick Rescue ครับจากพวกเรา Firefighter Alert ครับขอบคุณครับ
สวัสดีค่ะพวกเรานะคะเป็นตัวแทนกลุ่ม Crispy Egg ไข่ขาวอบกรอบจากมหาวิทยาลัยเทคโนโลยีพระจอมเกล้าพระนครเหนือค่ะผลิตภัณฑ์ของเรานะคะคือ Crispy Egg ไข่ขาวอบกรอบค่ะกลุ่มเป้าหมายก็คือกลุ่มผู้ป่วยนะคะที่เข้าสู่การบำบัดทดแทนไตโดยการฟอกเลือดด้วยเครื่องไตเทียมค่ะจุดเด่นของผลิตภัณฑ์ของเรานะคะคืออร่อยดีต่อสุขภาพมีโปรตีนสูงทานง่ายพกพาสะดวกทานได้ทุกที่ทุกเวลาราคาย่อมเยาเข้าถึงง่ายค่ะเพียงซองละ35 บาทค่ะโดยที่1ซองเนี่ยจะเทียบเท่ากับไข่ขาว1ฟองนะคะให้โปรตีน 3.5 ถึง 4 กรัมค่ะผลิตภัณฑ์ของเรานะคะจะแตกต่างจากท้องตลาดก็คือจะมีราคาที่ย่อมเยาวกว่านะคะโดยส่วนใหญ่ผลิตภัณฑ์ตามท้องตลาดเนี่ยจะมีราคาที่สูงนะคะเช่นอัลบูมินอัดเม็ดหรือว่าโปรตีนผงค่ะ
แผนการผลิตของเรานะคะภายใน1เดือนเราจะผลิตให้ได้ 1,500 ซองเพื่อวางจำหน่ายที่โรงพยาบาลเซนต์หลุยส์และเราจะผลิตให้ได้ทั้งหมด 5,000 ซองเพื่อวางจำหน่ายทั่วกรุงเทพและปริมณฑลมีมูลค่าอยู่ที่ 175,000 บาทโดยต้นทุนขนมของเรานะคะจะอยู่ที่ซองละ20 บาทเราจะมีการผลิตใหม่ทุกๆ10วันเพื่อความสดใหม่ของขนมค่ะแผนการตลาดของเรานะคะเราจะมีการโปรโมททุกๆ3เดือนที่โรงพยาบาลศูนย์ไตเทียมสื่อออนไลน์และงานอีเวนต์ตามห้างสรรพสินค้าค่ะเมื่อเข้าสู่ปีที่2นะคะเราจะมีการพัฒนาสูตรเพื่อเพิ่มสารอาหารและรสชาติให้ผู้บริโภคได้เลือกสรรหากต้องการติดต่อสอบถามเพิ่มเติมสามารถติดต่อได้ที่อีเมลด้านหน้านี้ได้เลยค่ะ